Good morning, everyone. Today, welcome back to JMC O-Level Seminar Series. Today, you are going to start our first science session. First of all, I would like to tell you about our science sessions. So now you have participated for few subjects up to present. So today we are going to start our science session. So you will have 3 science seminar sessions today, tomorrow, and on 28th. So today I would like to tell you I'm going to target some main questions you will have to face in the second part paper, right? So in that case, I am not going to the main structure of the question paper. Now, if you have already practiced some past papers in the O-level past years, you have a clear idea about how these paper questions have prepared, based on which lessons they have prepared, right? So then there will be some chemistry, some biology, and some physics lessons are there. Definitely these lessons are based on for some questions in the second paper. So first of all, I would like to tell you what are these lessons. Those who have not familiar with this paper structure, they can get a clear idea about what are the lessons you will have. You will have to face in the second paper. So mainly you will have to face this in biology. When you open your second paper, first you have to answer 4 questions, and they are compulsory and they are structured as a questions. So they are providing you the spaces to write the answers. But if you are not using the spaces to write the answers, and if you are writing these answers in a separate paper, that will be a problem for you. So then first note that you want to use the given spaces to write the answers in the structured essay part. So you will have 4 questions, and these 4 questions are based on several lessons, right? So first lesson you will meet there will be, it will be the chemistry, one of a biosphere lesson. You know what is biosphere? You will learn that, you have already learned that in the grade 11 last lesson, biosphere. So you will have a main big question at the very first of the second part, structured is a question. So biosphere, so that is mainly based on the theoretical part we are learning there, new words we are learning there, some environmental associated things. Sometimes if you have a rough knowledge in there, then you can manage this question to write the answers. So when you go to the second question, that will be mainly, most probably and most usually, you will have a periodic table. Sometimes these periodic table based questions are coming for structured essay questions and for some essay type questions as well. However, you will have to definitely face for periodic table associated question. So you will have to very familiar about the periodic table, its patterns, and the correct order of 1 to 20 elements, like that. Okay, and other than that, sometimes you will have to face the question which is based on plant and animal cell structures. Plant and animal cell structures. Okay. So what about other things? Photosynthesis. So plant and animal cells and periodic table are learning in a grade 10 syllabus. And when you go further, you will meet questions in the essay or structured essay part that is based on photosynthesis. Photosynthesis is also learning in grade 11 first term second chapter, photosynthesis. Those are very usual, most usual questions you will see in the past paper. If you are not familiar with the past paper question structure, you better to start seeing them. What are the lessons they have associated with when preparing the questions? So there are more than that. I want to give a start by mentioning these main lessons we have to note about, right? Okay, now we are going to go back to our paper. I would like to start the paper. Now, as I told you, the first structured essay question will be based on the biosphere, but I have not put the biosphere question today because from the tomorrow session, the instructor will discuss with you about the biosphere type of questions. So I have started some chemistry questions. So first you can see if you have the paper right now. So look at your paper and see they have given a periodic table. Sometimes they will give you a line with some specific elements. Sometimes these elements are not provided in the standard symbols. They have provided some fake symbols. At the beginning also they are mentioning that these given symbols are not standard symbols, and you have to answer the questions using the provided symbols likewise. So you have to see all the questions in at least past 5 years, how these type of questions have been provided. Okay, right. So I have given a sample question. Before we are entering to discuss about this question, I would like to tell you a small trick, right? Before you are starting to answer the question for science paper, second paper and also first paper, you better to write the periodic table on a extra sheet you are provided. Okay, so that's very important because throughout the paper in second and first part, you will feel very easy if you already have a prepared periodic table. You can't bring the periodic table from home. You can't bring any resource from the home to the exam hall. No. So after you are sitting at the exam hall, after you are provided some extra sheets and answer book, so you have to first thing you have to do is even before reading the question paper, you better to take some minutes. It will be less than 1 minute. So you can take less than 1 minute to quickly write down the periodic table. So today's at the beginning, I would like to guide you how to draw a periodic table memorizing the structure. Okay, sometimes there may be children who can draw that one alone. This is for the children who are not familiar with that. Okay, so we'll see. So can you raise your hand who are familiar with the 1 to 20 elements order? Very good. Those who cannot raise the hand at the moment, that means they have a small doubt, so small confusions about that order. Then remember, today itself, after this session, take some breaks. At least at evening time, you better to take your 1 to 20 elements order and memorize it. Okay, and also with their correct symbols, standard symbols, right? Okay. Now, let's see how to start that one, right? So, first of all, children, I want to tell you, we have only one first 20 elements order. No? So, there you will meet three special elements. Three special elements. What are those? If you can answer through the chat box. I have opened it. What are those three special elements in the 1 to 20 elements list? Who knows that? What is the name we call them? You can put a message in the inbox via Zoom. I would like to cooperate with you because I can get an idea about you and your knowledge. Okay, it seems like they have a confusion about that. Yes, very good. One, Habir has answered. Yes, there is noble elements. Those are called noble gases because they are definitely gases. At every situation, they are gas. Mainly, if you consider the room temperature, these elements are gases. So, they called noble gases. Why we call them noble gases? Why we call them noble gases? Why we call them noble gases? What is the meaning of noble gases? Now, you know, children, according to their number of protons and electrons in the atoms, some elements are there. They have the maximum number of electrons in each of the energy shell of them. Right? Now we know every element has energy shells. There is a nucleus, there is an atom, there is a nucleus. Around the nucleus there are energy levels. Each energy levels are allocated a maximum number of electrons, right? But if you consider the maximum number of electrons, first energy level should be with 2 electrons, other all are basically 8 electrons, right? So if any element has number of electrons with the energy shells which are with incomplete, which are with less than the maximum number of electrons in the energy level, they are unstable, right? So they are not considered as stable elements. So, but when you go to some other elements, you can see according to their number of electrons, the maximum number of electrons in their present energy levels are filled. So then they are stable, they are complete, right? So then other elements also would like to be like them, right? So those who have completed the maximum number of electrons in each of the energy levels are called noble gases. So tell me, what are the noble gases now? What are the noble gases? You better to cooperate. What are the noble gases? You can send me that in the chat box. 3 noble gases are there. Helium, neon and argon. They have, if you consider their energy levels, they have the maximum number of electrons in each energy level. So they are complete, they are stable. So other elements also would like to be like them. They also want to be stable, they also want to be complete like them. So that's the main idea about that. Now, why I told you about noble gases? Because when you start to draw the periodic table alone, you know the vertical rows are there, horizontal columns are there, and these are the main structure of the periodic table. Then when you are drawing it horizontally, you want to be familiar with the correct order of the 1 to 20 elements: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. In that order, you want to write them horizontally. So when you are writing, keep writing them horizontally, you have to get a better idea. You have to get a better idea from where I have to stop the first column, from where I have to stop the second column, likewise. Okay, right. First we are going to draw that. You see, first we are writing hydrogen. Okay, and keep a considerable space, because in the first period, there are only 2 elements in the 1 to 20 modern periodic table. Then we have to keep a small gap there and write helium. So we will make more than gap. Helium. Right? Hydrogen, helium. So what is the next one? Lithium. So I will quickly write down that one. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Are we continuing more? No, I told you every period should be ended up with the noble gas. So first noble gas was ended up with the first period. Okay, and the second period also ended up with the neon, second noble gas. Now we have argon. So third one is definitely ended up with argon. So neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, and then we are going to the fourth one, potassium and calcium. Right, now we are going to draw some lines to identify that. That is what we want to do in the exam, right? Before you are even reading the question paper, as a pre-work, you do this, and this is your most helpful resource in the exam, because we can't bring any other resource. The only resource you have in exam is your memory and your knowledge. So using that one, quickly draw this. So this is how we are going to draw the periodic table. Today itself, if anyone can't draw this one, memorizing it, you better to practice it today itself. Don't postpone that work, okay? Now I am going to mark the groups and periods. This task should be done quickly, right? This is a quick task, right? So groups are normally mentioned in the Roman numbers. And also the 8th group also called in 0, because this group contains only noble gases, no? So these noble gases do not have a valency. So that's why we kept it as a 0. Right, now we are going to mark the periods. First period, second period, third period, and fourth period. That's all, right? Okay, this is our periodic table. This is what we want to prepare before reading the question paper. Right now, we have a very special and important resource which helps us in the exam paper, right? Okay, now I would like to memorize again some patterns we are learning using the periodic table. I will explain all the key points based on this thing, and then I will let you to write the answers for that question I have provided. So after that we will discuss again based on this one, how do you find out the answers for the questions, right? Okay. Now listen here. Now remember, we have two things we are learning in that lesson in the grade 10. That is about first ionization energy and the electronegativity. First ionization energy, electronegativity. Okay. Now there is a small advantage, children. This first ionization energy and the electronegativity uh, both are changing in the same way in the periodic table. The pattern of first ionization energy and the electronegativity changes in the same way in the periodic table, but with only small difference, right? So first I will quickly tell you what is first ionization energy. That means I told you these atomic structure, there is a nucleus at the middle. Around there are energy levels, and electrons are situated in the energy levels, and protons are situated in the nucleus. Like that, no? So every atom has similar number of protons and similar number of electrons. If any atom has 5 protons, 5 electrons around there. Why? Then even though they are in two locations in the atom, they are having a attraction force, because this is protons means plus charges, electrons means negative charges. So each negative electrons are attracted with the each proton, positive charge proton. So it's not that easy to remove electrons by breaking the attraction force. So we have to, if you need to remove an electron from an atom practically, then it will not be an easy task, because each electrons are attracted by each protons. So if you are going to remove an electron at the last energy level of an atom, definitely we want to break the attraction force which is with this electron with the partner proton in the nucleus. So then how to do that one? We want to put some energy. Like when two best friends are holding their hands and not like to go home. In small ages we are like that, no? So then we have to apply a large force energy to take them apart and to take one of them into the home. So like the same way, these electron and proton has attraction force. Every couple of proteins and electrons have that force. Then we want to break the force and have to apply some energy to take the electron out from the atom. Then what is the minimum energy we want to apply to do that task? That is what we call first ionization energy. Remember that. Okay. Then when you go to electronegativity means when there is an atom in a compound, like example A and B like there, and PQ is there, then when they are meeting together, B has how much of an attraction to attract another element towards itself. So that's the basic idea about electronegativity. So these both are changing in the same pattern of the periodic table. Remember that. Okay. So then how they are vary in the periodic table. How? First ionization energy and electronegativity both are increasing from left to right along a period. Remember that. Left to right along a period, both first ionization energy and electronegativity increases. Right? Then if you want to find out who are having a higher first ionization energy and electronegativity out of the 20 elements, these three are having the highest first ionization energy. Okay. For now, forget about the electronegativity. If you take only the first ionization energy, the largest first ionization energy is possessed by the right side corner elements, because when going along a period, the right side corner ones having the highest first ionization energy. Then what about the left side corner ones? They have a low first ionization energy. Now we know how they are changing along a period. Now when you consider along a group, who remembers how it is changing along a group, how the first ionization energy increases from bottom to top or top to bottom? Who knows that? Quickly send me an inbox email message. No one has any idea about that? If someone would like to answer, they can raise hand. I can unmute them quickly. Here's Naziha. You can answer.
It decreases from up to down along a group.
Along a group, what?
From top to bottom, first ionization energy decreases.
Yes. What she says. So what is the actual changing there? Thank you. What is the actual thing happening there? From bottom to top increases the first ionization energy. If you are answering the questions that I am asking, if you are wrong, then definitely you will remember that forever, because whenever you are making a mistake, then you can understand and then okay, this is my mistake and I have to remember this forever. I'm just saying, because there are some students, they think it can be wrong, then I will be shame in front of others. Then don't be shy, answer. Then here you have come to learn something, no? So gather as much as possible you can. Okay, thank you for cooperating. Now from bottom to top. Okay, bottom to top increases along a group, and from left to right increases along a period. Okay, now I think you have a clear idea about the variation. Now I told you to forget electronegativity for a while. Okay, why? Because electronegativity, I told you, if any element has ability to attract someone else toward itself to have a bond with it, that's what electronegativity know. But according to the nature of the noble gases, they don't want to attract anyone. Because why they are attracting anyone else? Because they are completed. No, why any element is attracting another element towards itself? to have a bond. If they don't, why they are making a bond with others? Why? Because they are not completed. If they want to complete, they have to fulfill their shortage. Sometimes some elements are there. If they receive one electron from someone else, they are becoming complete. Then they are looking for someone who likes to give one electron to itself. So then while they are looking for someone who likes to give one electron to itself, and once it met someone who likes to give one electron, they are having a bond with that one. So, but helium, neon, argon, they don't want to release electrons. They don't want to give electrons to someone else. They don't like to take electrons from someone else, because if they do so, they will become unstable, incomplete. That's why. Okay, so then once they have completed, they don't want to have a bond with anyone else. So they are not going to attract anyone else. So then they don't have electronegativity. So it is very useless to consider the electronegativity, because they don't have an electronegativity. So I told you at the beginning, first ionization energy and electronegativity both are acting in the same way in a periodic table. Yes, but when you consider the variation of the electronegativity of elements, we want to consider these helium, neon, argons are not there. We want to pretend like 8 group has removed from the periodic table. And then what is the remaining periodic table you have? Using that one, you want to consider the same pattern. Okay. Now what I told about first ionization energy, along a period from left to right increases, along a group from bottom to top increases. Same way in electronegativity, but we want to pretend that last group is not there. Okay, so you pretend like this group is not there. The periodic table is only up to here. Then electronegativity again increases from left to right along a period, and it is increasing from bottom to top along a group. That's the thing. So then I'm going to ask you some questions. Now you have about idea about first ionization energy and electronegativity, both children. Now tell me, considering the whole periodic table, someone asks you who has the highest first ionization energy. Tell me. Raise your hand. Yes, Buddha, you can tell me.
Helium.
Helium. Very good. Is it correct? Yes, helium. Why? Because children, helium is the, now when you go along a period, I told right side corner ones has the highest first ionization energy now. And now we have come to one single group. Now we want to consider about the pattern in a group. In a single group, along a group, when you go from bottom to top, you will meet the highest first ionization energy, then according to helium. Now tell me who has the least first ionization energy?
Potassium.
Yes, very good. Potassium. Potassium has the least first ionization energy because it is in the left side corner, because left side corners have the least first ionization energy. Now we have come to one single group. From bottom to top only increases, then top to bottom it is decreasing. Then potassium is the least first ionization energy. Now tell me about electronegativity. Which element has the highest electronegativity?
Fluorine.
Yes. Fluorine. Yes, fluorine. Why is that? Because we don't consider the last group in electronegativity. That's why. So it's up to only here. Then you are going along the right side corner ones are fluorine and chlorine. Now we have come to the same group. When you go from bottom to top, it has the highest one. Okay. Least electronegativity. Who has the least? Yes.
Potassium.
Yes, Buddha. Very good. Okay. Potassium is the least one because we consider this group, no? Right? So, highest one only changing, lowest one of the first ionization energy and electronegativity both are same. Okay. Thanks for cooperating. Now, okay. Right, these are the things. Right. Now, I want to direct your knowledge, your memory to something else, another thing, okay? Right, children. Next, I would like to tell you about metals, non-metals, metalloids, these things. Okay? Right. So, what are the metal here? Before you are listing out the metals and non-metals, I recommend you to first memorize what are the metalloids, because how many metalloids are there in this periodic table? Tell me, who knows that?
2.
Two. Very good. Who are those? Who are those?
Boron and silicon.
Silicon.
Very good. Boron and silicon metalloids. Because why they call metalloids? They have a hybrid characteristics. They have some characteristics from metals as well, non-metals as well. Sometimes neither characteristics they hold. So that's why they called metalloids. Now, first we are going to mark the metalloids. Okay. These are the metalloids. Right. Now, how you are going to identify metals using that one? You take them as a boundary lines, okay? Now see, I'm going to separate that two from others. Okay? Right. Now, the metals, rest of the metals you will have here. The left side elements of the metalloids, all are metals. But you will have problem hydrogen also in the left side. But we know, in our general knowledge, we know hydrogen is a gas. Gas cannot be a metal. Okay, gas cannot be a metal. So that's why except hydrogen, other all left-sided elements of the metalloids are metals. Remember that. Okay, these are metals. Right. Now we are going to consider about the non-metals, children. Now it is very easy. Non-metals are who are in the right side of the two metalloids. So these are non-metals. These all are non-metals, including hydrogen. Hydrogen is there, but inner side we know hydrogen is a gas. So gas is definitely a non-metal. Okay. So these are non-metals. I hope you can see them. Right, so 2 metalloids, 1, 2, 3, 4, 5, 6, 7 metals, and other all are non-metals. Okay, I hope you can understand now, right? And 2 more thing I want to memorize, recall. Other thing is, tell me, from this one, this is a very usual word you will meet in the exam questions. Allotrophic forms. Which element throughout the 1 to 20 elements have allotrophic forms?
Carbon, silicon.
Yes, carbon and silicon. So, silicon also have allotrophic forms. Carbon also have allotrophic forms. But the examples that we are learning for allotrophic forms is carbon mainly. Both have allotrophic forms, remember. And for carbon, we know what are these allotrophic forms. Tell me some more. Some allotrophic
Graphite,
forms of carbon.
diamond,
Diamond,
gold,
graphene.
Sorry?
gold, graphite, diamond, gold.
Very good. Graphite, diamond, coal, right? So if you check your textbook, grade 10, chemical periodic table lesson, you can see what are the lattice structure of the graphite and diamond. Because of their different lattice structure, they have different physical properties. When you take graphite and the diamond is the hardest material in the world, on the earth. But when you go for the graphite doesn't have that much hardness. If using your fingers also you can, it has a very high brittleness. It's breakable, easily breakable. So that's the one thing. Another difference, if you recall, what about other differences between graphite and diamond? Tell me.
Graphite, good conductor of electricity. Graphite, poor conductor of diamond, poor conductor of electricity.
Yes, very good, Puta. Thank you. Right. So because graphite is taken as a good electricity conductor. Even electrolysis, we are using carbon electrodes. No, as a carbon electrodes, we are using graphite rods, right? So they are very good electricity conductors. But diamond do not conduct electricity. And when you go further, luster. right? The refractive index, the refraction. So when you direct light on the graphite, it's not that much refracted, right? Because its refractive index is very low. But when you consider diamond, we use that for jewelries as well. Why? Because it has a high refractive index. These are the things. Why that happens? When you go to the chemical composition, graphite also contains only carbon, diamond also contains only carbon. According to their bond, according to how these carbon atoms are bonded with each other, their lattice form, lattice structure is changes. Because of that one, so many physical properties are changing. Okay, thank you for cooperating. Now this is the main idea. So the very last point I want to remind you is this word, amphoteric. Amphoteric oxides. With this word, what is the element familiar with you?
Aluminium.
Very good. Aluminium. Aluminium. Why? Why we call him amphoteric oxide? Aluminium react with oxygen and make aluminium oxide. And that is not acidic or basic or neutral oxide. That oxide is taken as amphoteric oxide because it has a mixed it has a mixed up characteristics of acidic and basic nature, right? Example, aluminium is at the boundary line of the metalloid and the metals. No, it is a metal, but you can see when you compare sodium and aluminium, sodium has the highest metallic features. But when you compare with the aluminium, aluminium is like නිකන් එයා metalloid වෙන්න ගිහිලා බේරුණා වගේ, right? So it is closer to metalloid side, right? But it's not a metalloid, but නිකන් ලං ගිහිලා පොඩක් බේරිලා වගේ. ඒ නිසා it has a metal and non-metal mixed up නිකන් අර මැද මේ features වගේ තමයි තියෙන්නේ. So that's why when aluminium converts into an oxide, that is called amphoteric oxide. මේ words එක you have to remember with the word. හැම වෙලේම there is a key word and what's it associated with, which element is associated with this word? Allotrophic, carbon, silicon. If it is carbon, graphite, diamond, coal. And when you go for amphoteric, that is definitely aluminium. Right? Those are the metalloids, boron and silicon, like that. Okay? Right. So next two things I want to remind you about the oxides and hydroxides made by the metals and non-metals. Remember, metals, when metals react with oxygen, they make what type of oxides? Basic or acidic oxides? Tell me.
Basic.
Basic.
Basic. Very good. Basic oxides and hydroxides. How hydroxides are formed? By reacting with water. When any metal is dissolved in water, they quickly turns into hydroxide, and that is a basic hydroxide. If it is an oxide, metallic oxides are basic oxides, right? When you go to non-metals, what about non-metals, children?
Acidic.
Yeah, they are acidic. Now that's all you have to remember. We'll see whether we have missed anything. Okay, we will switch into the question. Okay. Right. Now I will give you some time to answer the questions of this paper. Right. You will have 6 sub-questions based on this one, children. Now you have to first quickly write down a periodic table in your book or in a paper. Quickly write down the periodic table and you try to answer the questions. I will give you 2 minutes for that. Take your time. Okay. So I think it's enough time to clarify. If anyone needs some time, first raise your hand. Okay, I will give you a few seconds. Go through that one quickly. Because only if I am discussing and discussing continuously, there will not be any use. That will be pointless. You also have to give your attention personally in the each questions and try to clarify. Okay, take some seconds. Okay, children, I think enough time. Okay, we'll see. Okay, now I hope you also have prepared a periodic table by yourself. Right, we'll see. Now, there is a important fact they have mentioned there. What it is? A part of a periodic table is given below. The symbols given are not standard symbols. Remember this. The symbols given there are not standard symbols. Okay. Remember this part of the phrase. And also they tell you to provide answers associated with the given symbols. Why I am highlighting this again and again? Because in my experience correcting the answers in exams, most of children, okay, majority has written the correct answer but has not delivered according to the question is expecting, right? That's a big problem. So according to the marking scheme, we can't allow the marks for them, right? You have understood the question and you have delivered the correct question, but the way you have presented it is not the correct way. If they expect the answers associated with the given symbols, please write like that. But if they haven't mentioned anything like that, then you have freedom to write either with the correct standard symbol or with the given symbols. Okay, now in this type of a situation, children, right? In this type of a situation, some children may confuse. These are not standard symbols, no? And also boron is B, but here the boron, the B is representing beryllium. So it's so confusing. Yes. Then what I recommend you to is, now you have your periodic table. By comparing with that one, quickly write down what is the exact element nearby this, and after that you can erase it, no? Okay, use the pencil and write the correct standard symbol instead of the given one nearby that one. So when you write the answer, you think according to the actual element, and when you write the final answer, you write in the given symbol. Okay, that will be easy, not a hard task, right? So right, so this is the periodic table, no? So what can be this then? What is this? This is what? Beryllium. Okay, so beryllium. This is beryllium. Okay, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. This is oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Okay, I hope you have identified. Raise your hand who has identified these correct elements? Yes, very good, Puta. Right. Now we will start the question, right? Write the electronic configuration of very simple questions. Write the electronic configuration of the element B. Now B is beryllium. 1, 2, 3, 4. Fourth position. Then it has 4 electrons. Then how to fill them? 4 electrons are there. 2 electrons are filled here. And maximum 2 only can be filled in the first energy level. So other 2 should go to the second energy level. Okay, who wrote the correct answer for that? That's a simple question. Right, very good. Right, we'll go to next one. What is the noble gas mentioned above? Tell me. Oh, I have
A.
missed that. This is helium. A is the noble gas, no? If you are writing helium, you will get marks. No, you won't get marks. Okay, that's wrong. Okay, right. A is the noble gas because noble gas is in the same period. So nothing to do more, right? What is the physical state of E at room temperature? E is what? Chlorine. Chlorine is in which physical state at room temperature?
Liquid.
Are you sure?
Gaseous state.
Yes, remember children, please be familiar with their physical state, okay? We can't just memorize it. You just see what are the physical states. First, you have to be familiar with that one, okay? Thank you for cooperating. So, this is a gas. Gas, so you can write gaseous state. Okay, all right. Now, we have to go a part we are discussing again, mass number. Atomic number. Tell me what is atomic number? What is atomic number?
Number of protons in an atom.
Yeah, number of protons in the nucleus of the atom. Okay, that is atomic number. And also the atomic number, from the atomic number we can get the idea about how many electrons are also there, because I mentioned at the beginning of the session what is the atom, how many protons are there, same number of electrons are there. Then okay, right. So what about the mass number?
Number of atoms, number of neutrons and protons in the nucleus.
Yes, number of protons and neutrons. The sum of protons and neutrons. So, mainly the theory is proton plus neutrons. But if you know only number of electrons, electrons and neutrons sum also can be taken as mass number. So, mass number of D. What is D? D is sodium. So mass number of D is 23. Okay. So that means protons plus neutrons of sodium is what? 23. That's what they are telling. Okay, this is not the answer. This is what they are telling. Okay, then they ask write the number of protons and neutrons of atom D. To find out the protons, we don't need any calculation, right? We need only its position. What is the position of the so-called element? It's the number of protons and number of electrons. So according to that one, so nitrogen is in which position, children? Nitrogen is in which position?
Teacher, they have asked
It's
about
in the
sodium.
11th position, right? So then how many protons are there? So protons are 11, right? Neutrons. Okay, now 11 plus neutrons only 23. Then how to find neutrons? 23 minus 11. So how many? 12 are there. Okay, right. Tell me, is there any problem, any doubt here? Please don't hesitate to ask about the calculation. I hope you can understand, right? Okay. Right. Now we are going to the next question. Right. Out of B and F, which has the highest first ionization energy? Out of B and F. What is B and F? B is beryllium, F is calcium. So don't want to even know the standard element. By looking at the pattern of the periodic table, we can say it. B and F both are in the same group. Right? Both are in the same group. Then we want to consider the pattern along a group. From bottom to top increases. Then who has the highest first ionization energy?
P.
B.
P. If you wrote beryllium again, you will not get the marks. Okay? B is the answer. Very good. Right. Write the chemical. This is a very important part. Most of the times you will have to get the help from chemical formula. It's very important part. Okay. Write the chemical formula of the compound between element F and C. Okay. I would like to remind you how you have to go through to find out them. I will take this space. Right, children. Then how you are going to write the chemical formula. What is the thing? What quantity helps us to find out the chemical formulas of the elements? That's
Valence.
valence. Yeah, electrons. Number of electrons and its valency. How do you know valency? Valency means I told you there are a lot of elements. They are not stable. They like to be stable, right? They are waiting for someone to complete their shortage, right? In that case, in that process, every time they are finding out easiest way to become stable. I'm taking a small example here, magnesium. Okay, magnesium is 12th. Electronic configuration is 2, 8, 2. So it's not stable because of this one. Because it's in the third energy level now. So after the first energy level, every energy level should be with maximum 8 electrons. But here, the third energy level is not with 8 electrons. So it is not stable. How many it needs to become stable? Normally, if you see this one, yeah, so it has every element has two options. Every element has two options to do that one, but they choose the easiest way, right? Two options. If you just go to the very basic part, okay, either if the magnesium can find out another 6 element from someone else, it can make it as 8 and become stable. Another option is it can find someone who likes to take its 2 electrons, right? So it can release 2 electrons and these 2 also will be removed, no, then 2, 8. Okay, then that is also a kind of a stable configuration. Then what is the practically easiest way? Finding 6 or releasing 2. Releasing 2 is the easiest way. So they are choosing the easiest way by themselves. Right? So what is the valency of magnesium? It is 2. That's how the valency is clarified. Okay? Right. I hope you can understand. Right? Okay. Now I am going to consider about magnesium. Right. Now, I want you to find out the chemical formula of magnesium and chlorine. Take some time.
MgCl2.
Yes, MgCl2. How, children? Okay. If anyone asks, I know majority of students don't have a clear idea about writing the chemical formula. That's why I am taking this much time to describe this. Okay. Don't have any confusion about chemistry after today's session. Okay. If you got any confusion, ask me. Don't hesitate. Right. Magnesium. Magnesium is 12. Okay, children. So 2, 8, 2, no. So as we discussed, yes, the most easiest way of magnesium to become stable is releasing that 2. Okay. So it is releasing 2 electrons. Right? Chlorine is 17th. 2, 8, 7. Right? So what about chlorine? Chlorine is, it also has two options, releasing 7 electrons or receiving 1 electron. Easiest way is receiving 1 electron. So it is receiving 1 electron and becomes stable. So when you consider their valencies, right? Magnesium's valency is 2, chlorine's valency is 1. Then they exchange. Not actually happening that. This is how we are writing the chemical formula. First we take that elements, writing their electronic configuration and mentioning their valencies and exchange them. So magnesium gets the valency of chlorine, chlorine gets the valency of magnesium. So finally we write magnesium chloride. Magnesium gets the 1 of chlorine. So we don't write like this. If it is 1, we don't write 1. Remember that. Okay. Next thing, chlorine gets 2. So this is how to write the chemical formula. Okay. So I will give you some time to write the answer for that one. No, I have given the time now. I think you have done it already. Okay, children. So F and C, right? F is calcium. F is calcium. Calcium is 2882. 2882. So calcium also would like to release 2 electrons to become stable. Its valency is 2. When you go to F and C, C is oxygen. Oxygen is 8. Then 2, 6. Valency is 2. Okay. They are exchanging, yes. But you can see if the valencies are divisible, right? We can cancel them, simplify and then exchange. Remember that, okay? 2 by 2, 1, 2 by 2, 1. Then their new valencies are 1 and 1, 1 to 1. Then they are exchanging. Nothing to write. Calcium also gets 1, so we are not writing 1. Oxygen also gets 1, so we are not writing 1. Finally, you have calcium oxide. This is your rough work. Okay. Now, substitute the given symbols. Calcium is F. So, F. Oxygen is C. FC. Who wrote that answer? Raise your hand. Okay, right. Those who don't have familiar idea about about writing the chemical compounds, children, please take some names of the chemical formulas from the textbook, right? In the 3rd unit of grade 10 first part textbook, at the end of the lesson, they have given so many names of the compounds. So you take them and practice how to write the chemical formula. That is very, very important to manage the O-level chemistry questions. Right. Okay. Now we have almost done our first question. So as I told you before, I made that much of a huge explanation on chemistry because most of children just look at the question from the first sight haters wage. From the first sight, chemistry I can't do that, I skip this. No matter how many marks are allocated, no matter how many marks you will lose in the exam, you just look at that one, chemistry, calcium, helium. I'm not doing that like that. But if you see the question, we can't skip the chemistry, right? So if once you are familiar with the clear idea about each lesson, you will not skip the questions based on chemistry. And you will first do the chemistry. Okay? Right. Now, we have come to the second question, children. That's about a physics lesson. That's also in the grade 10 second unit. Okay? Motion in a straight line. In there we are learning several formulas and about the graphs of motion and how to gather the informations from the given motion graphs and likewise to analyze it. Okay, so first I will give you a quick I will quickly go through the key points of the lesson, highlighted part of that lesson as well, right? Right. Let's start about the motion in a straight line. So first few things we are learning some quantities. First we are learning vector quantities, scalar quantities, you know that one. Vectors have both definite magnitude, a value, and a definite direction. And if you go to the scalar quantities, they have a magnitude only, a value is there, but no definite direction. Some scalar quantities do not have a single direction, some have so many directions, that's why they are scalars. Okay, now what are the quantities we are learning throughout this lesson is displacement. Next thing I want to tell you is, please be familiar regarding the symbols we have provided for the quantities, because once you are familiar with the given symbols, like in maths also you are doing no radius is simple r, likewise. So in physics we have lot of like that, even in chemistry. So simple m is mass, capital M is smaller mass. In physics displacement is s, velocity is v. Be familiar with that one, so that will be more helpful for you to memorize the formulas. Okay, right. Now this S, displacement. Right, velocity P, acceleration. If it is a deceleration, children, the acceleration amount will be a minus value. Remember that one. If it is a minus value, we take it as a deceleration. T, time. Okay, right. These are the things mainly in motion in a straight line. Okay, so displacement. Displacement is delivered in, next important thing is our measuring unit. Some children are doing all the calculation accurate way, but the final answer delivered with the wrong unnecessary measuring units. So they won't get the complete marks allocated for that one. And next thing, remember, if you, before you start a calculation, first you write the equation or show the substitution. Writing a substitution or the relative equation accurately, you will get 1 mark for that one. So even though if your last answer is wrong due to any confusion in the calculation, at least if you have written the relative accurate formula, then you will get that 1 mark at least. Please write the formula because of that. Okay, meters. This one, meters per square second, meters per second, and meters per square second, ms minus 1, ms minus 2. Deceleration also same thing, and time in seconds. Time in seconds, remember that. Okay, right. Now, what are the formulas we are learning there is, what are the formulas associated with this? We learn V equals S over T, A equals V over T. This is the main two. These are the main two ones. Okay. Here remember, when you consider the displacement and velocities, we want to take their difference. Delta S, delta T. Delta V, delta D. Delta means difference. Don't be scared on the delta. That's a Latin letter, and that is representing in maths and physics about a subtraction. Okay. So when you consider 2 points, right, what is the ending velocity, what is the initial velocity, their difference. What is the ending time, what is the starting time, their difference. That's what only we want to divide, right? So this is the main idea about that. Okay, now next I want to direct your mind into the graphs of motion, right? I will clear this. Graphs of motion, right? In their children, we have only 2 types of graphs. ST graphs, that means displacement time graph, and VT graphs, velocity time graph. Velocity time graph. These are the 2 graphs you will have. So, I will tell you what are the key points and what are the informations we can gather from each of the graphs. Okay, right. I think some are having the clear idea about that one. We'll see. Right. In ST graph, remember, what are the direct informations we can gather from ST graph? Tell me. By looking at the graph, what are the things we can obtain? Tell
Time
me.
and displacement.
Yeah, time and displacement. By looking at this one, okay. Displacement is 80. Time is 20. We can get the direct information about displacement from the y-axis. Right? Time from the x-axis. Just have to look at the scale and just tell me about that. Okay. Next, there is a hidden information. What is that?
Velocity.
Very good. Velocity. By looking at that one from the outest appearance and the provided things, we can get the direct idea about velocity, direct value of the velocity. We have to do a small calculation, right? So, velocity, how to calculate? Now, children, remember, we have informations about displacement, S. We have informations about time, T. We want to find out velocity. So what is the most suitable equation we can use from these two? First equation. Because V is founded out, we have to find the V and we have the informations about S and T from the graph. Then how to find the velocity in a ST graph using the formula? Using this. And also, this is about the velocity value, no value of the velocity. And what about the nature of the velocity? So, velocity have different nature, no? If the velocity is same in the duration, that is
Uniform
called
velocity.
constant velocity, yes, or uniform velocity. How do we know whether it is a uniform velocity or not? If the velocity is not constant, there can be two things, either increasing velocity or decreasing velocity. If velocity increases, that is acceleration. If velocity decreases with time, that is deceleration or retardation. Okay, then how do you know whether it is a constant velocity or acceleration or retardation? Remember, look at this one. If the ST graph represents you about a velocity increment, okay, it will be a curve, increment curve, increasing. Okay, right? That is telling you about displacement increases, right? But not with the uniform velocity. You can see displacement increases now 1, 2, 3, 4 in different points. It's increasing. Value increases of the displacement. Time also counting. What will happen? Why it is a curve? Because the object is moving with changing the velocity, mainly increasing the velocity, 2 ms minus 1, 4 ms minus 1, likewise. Okay, so this is telling about, this shape is telling about the acceleration. You don't memorize because the same shape in VT graph is representing something else. Okay, that's why I am telling not to memorize. You just get the idea, it is increasing, then the object is moving forward. If the displacement increases, object moves forward. And it's not a straight line, then it's not a uniform velocity, it's acceleration. Okay, right. Then how about the deceleration, children? Now the object is moving forward but decreasing the velocity, right? So deceleration or retardation is mainly taken as like this curve. The curve is getting low. Curve is bending. Okay, bending to the left side, right? Lower side, getting lower. The curve is getting lower like that. Okay, right. Now next thing is, what about that? Black. Next, uniform velocity. If it is a uniform velocity, very nice. Straight line, very nice. Okay. A nice, perfect straight line. Increasing, displacement increases, that means object is moving forward, but with the uniform velocity. Nice. Okay, right. Okay, then how to know the velocity's nature? Whether velocity constant, or is it acceleration or deceleration? That is mainly taken by the shape of the line. Shape of the line. And other, if you need to find out the answer for velocity, the value magnitude of the velocity is taken by this formula. Okay, right. This is about the velocity, displacement time, and the information gathered from the ST graphs. Okay, before we are going to our main question, I would like to give you a small calculation here. I will give you a small instance, example. You try out that. Okay, right. I will draw that on the board. You quickly find the answer for that. Children, if you want to note down, you can note down that now. In below, this is just like a short note, you can consider like that. Below I will give you the new displacement time graph and some questions. You answer that question quickly to get a practice, right? I will do a displacement time graph here. So, okay, here children, I will mention what are the things you want to find out here. First you try to describe, right? Describe the motion. Describe the motion. Like from 0 to 2 seconds, what has happened? How it has moved. From 2 to 4 seconds, how it has happened. From 4 to 6 seconds, how it has happened. Okay, try to write that. Second, you find out the velocity of last 2 seconds. And number 3, this is a very important question. Total displacement. We'll see who will write the correct answer for third one. Total displacement. Okay. Okay, I'll give you 1 minute, 2 minutes to clarify this question and try to write the correct answer. Don't memorize anything. Okay, again I'm telling, just get the idea. Practically think what is happening. Practically think and write the answers. Okay, children, are you done? Okay, we'll see. Okay, I would like to erase this upper side. I hope you have note down the things you need to note down, right? So while you are doing this one, if anything is important for you and you have not noticed before, you keep a quick note on that. Right. See. Right. See here now, first they ask you to describe, okay? Describe the motion. So when they ask you to describe, don't write in paragraph wise. This is not a literature question. No? So try to make your task easy. So separate your motion into timelines, to durations. And I recommend you first to mark the durations in your graph, whatever the graph you get before answer the questions, you quickly write down the durations. That will be easy for you, right? From here to here, duration is 2 seconds, right? From here to here, duration is another 2 seconds. From here to here also another 2 seconds, right? Okay. Now, we are going to describe 0 to 2 seconds, right? 0 seconds to 2 seconds. What is the type of motion? Tell me. What is the type of motion?
Uniform velocity.
Yes, uniform velocity. Thank you. Good. I would like to include one more thing. Okay? In displacement time graph, children, we can see whether the object is moving forward or backward. That also can be detected. Right? So we will write that as well. Remember, if someone is starting from here and moving forward, that means that person or that object is updating the displacement. Displacement increases. Okay. 4 meters. Just I am giving a small example. Okay. Now time is going, but still 4 meters. Time is counting, still 4 meters. That means it has stopped here for a while. Right? If same displacement continuously recorded, then that means that object has stopped. Time is going, okay? Time is going, but the displacement is same. It's not updating or it's not downgrading. Nothing happens. So then object has stopped. Remember that object is at rest. Okay. Again, displacement decreases. What's the meaning of displacement decreasing?
Returning the original position.
Yeah, it is coming to backward, a reverse motion. It comes back, right? Comes back 1, 2, 3, 4. Again, if the object is coming to the same position, displacement is 0. Remember, you also, now you are sitting in a chair or somewhere, no? Right? So you are standing, going to kitchen and coming back to the same position. Your displacement is 0. Why? Because you have come to the same position. So if you are calculating the displacement of your lifetime, right? So if you are dying in the same place you have born, then your displacement of your lifetime is 0. Like that, you just get the practical idea and then you don't want to memorize that, okay? Right. Okay. So to describe that one, 0 to 2 seconds, you can see the displacement is increasing. So as that Putha said, it is uniform velocity because it's a nice straight line, no? Right? And also on the other hand, as I told you, displacement upgrading, that means the object is moving forward. So moving forward at uniform velocity. Right. Okay. Now 2 seconds to 4 seconds. Right, children? 2 to 4, what's happening? Tell me now.
Object is at rest.
Object is at rest. So as it is a straight line, can we write uniform velocity? No, not uniform velocity. Velocity means a type of a speed with a definite direction. So if I am at rest, do I have a velocity? No. So nothing to tell about the velocity. Velocity is 0. So we should write object at rest. Okay, right. 4 to 6 seconds. What's happening there?
The body turns back and returns to original position.
Yes, very good. So object moving backward at uniform velocity. Velocity is uniform because it's a nice straight line.
Backwards.
So, yeah, moving backward at uniform velocity. If you need, you can write becomes rest. Yes, no? It's coming back to 0. Here at the last, very last point of that timeline, right? Displacement is 0. If the displacement is 0, that object has come to the same position. You can write come to the same position. Moving backward at uniform velocity and coming to the same position. Right? Original position. Right. So that is how the description. If anyone didn't write, quickly write down that one. Okay, we will go back to the second question. Here, have another question. Question number 2. Right. Velocity. Now you know in ST graph, then small short note. You can see, okay, in ST graph, how we are finding velocity? Using the formula. So, velocity equals delta S over delta T. Right? So, if you are writing this one, no, either substitution, you will get 1 mark for that one. So, don't lose that mark. Right. Okay. So they asked the velocity of last 2 seconds, children. This part, okay? In this part, displacement is what? 80. Time is, time. Tell me what is the time?
2
What's the
seconds.
time of that part? Is it 6?
No, 2.
No, 2. Why? I told you to take the difference, right? Delta means difference. Take the duration. That's why I told you before starting the question, to answer the question, write the duration of each section. Then even though if you forgot about difference, delta and other things, when you look at the graph, you can identify, this is not 6, this is 2. I'm telling this, these are very frequent mistakes made by the children. So they will lose the marks unnecessarily. So don't do that one. Okay. So 2. So use some tricks. You have to be some tricky in the exam paper to less your mistakes. Right? Okay. So answer is what? 40. Right. Go back to what? What you have found? Velocity. What's its measuring unit? Meters per second. MS minus 1. Who got the correct answer? Raise your hand who got the correct answer. Okay, very good. Last one. Total displacement. What's the total displacement?
0.
Yes, 0. Why? It has come to total means now you have to go along the graph. මුලින් ඉඳලා යන්න නිකන් මෙහෙම බලන්න මොකද උනේ? 0, 80, 80, 80, 80, 80 and then it's decreasing coming to 0. Go to the very last point of the graph. This is the very last point of the graph. It is aligning to the 0 of the displacement axis, then 0. So for the third one, answer is total displacement is 0, nothing more. Okay, right. Who got that answer as 0 before I'm explaining? Very good. Okay, right. Now we are going to VT graph quickly because our exam paper question is based on VT graph, right? So you have to get ready for both type of graphs. Right. Now children, in a VT graph, what are the things we can gather? We'll see, okay? V, ms minus 1, t, seconds, right. Okay. What are the direct informations we can gather from VT graph? Tell me.
Velocity and time.
Velocity and time. Velocity from y-axis, time from x-axis. Velocity can be gathered from y-axis. Time can be gathered from x-axis. By looking at the graph, we can say about that. What is the... Now, here two hidden informations are gathered from VT graph. Very interesting. Okay, what is the first hidden information we can gather from the VT graph?
Displacement.
Displacement. Another one?
Acceleration.
Acceleration. Now this is VT graph, no children. V and T have associated with here. Other S and A both can be obtained from there, but they are hidden informations. We have some special methods to find out them. A is nothing more, acceleration. Want to find acceleration? Then nothing to do. V knows, T knows. We want to find A, then what is the suitable formula? This is what. If you use this formula, you can find out acceleration, okay? A equals delta V over delta T. By the formula, we can find out about A, acceleration, using a VT graph. That's about the magnitude, okay? If you want to find out the nature of the acceleration, like we did for velocity in ST graph, how the acceleration also in several ways. Acceleration also uniform. If same acceleration continuously taken, or same deceleration happens, or if the acceleration also increases or decreases, right? So, how to know that one? Remember, these are the shapes. See, if it's a nice line, okay, nice straight line, it's not nice. If it's a nice straight line, first see what happens to velocity. Time is counting, nothing to talk about that one. Velocity increases, no? Here, 1, 2, 3, 4, like that, velocity increases. Okay, velocity increases in how way? If it is a nice straight line, remember, acceleration is uniform, not velocity uniform. You can see, how velocity increases, how velocity can be constant. It's not constant. Velocity increases. You can see that, okay? Why I am telling you, most of the children writing, that one also uniform velocity, no, in ST graph, they think this is also uniform velocity. They don't use the practical knowledge. They don't see it practically. See, velocity increases, how it can be uniform velocity, right? Velocity increases in a nice line, then it is uniform acceleration, okay? This is about uniform acceleration, right? Uniform acceleration. Now, if it's not uniform, just an acceleration, velocity increases with an acceleration but not uniform, then this is the curve. Accelerate without any uniform constant gap. Okay, right. What about the uniform velocity then? How to know uniform velocity? Uniform velocity means it's a straight line like this. Same velocity, see? Same. If it is 80 or 40 or 4 or 6 or whatever, from here to here, same velocity. Then uniform velocity, constant velocity, same velocity. Other one, this. Now what's happening there? Velocity gradually decreases and becomes 0. Velocity becomes 0 means what has happened? Object has become rest. It has stopped. Driving a car, okay, right? It has stopped, right? Okay, now velocity decreases. Velocity increases means acceleration. Velocity decreases means retardation or deceleration. Here the object is decelerating but uniformly. Why? Because it's a nice straight line. Remember that, okay? So uniform, not an acceleration, it's a deceleration. Right? That's the thing. Okay. Now, I will gather that into one single graph. You can have a quick note on that. Sometimes there may be children who already knows these things, but I'm targeting on the ones who have any confusion they can clear after this session. No? So that's why the ones who are already familiar with these things, just recall them, okay? Refresh your mind. Right, children. Now, this is what? Uniform acceleration, uniform velocity, uniform deceleration or retardation. Okay? Right. Next thing. Okay, last hidden information. I told you 2 hidden informations can be gathered from there, no? Right? What it is? Next thing is, one of you said it's displacement. Okay, displacement. For that we need maths knowledge, our maths knowledge. What is the maths quantity, maths lesson we associated with this
Area.
part? Yes, very good. Area, right? Area. Find the area and deliver the final answer in meters, because this is not, definitely remember that thing. For that one, we have to get the help from area. Okay? Area of the figures. We find area, but remember, at last we want to deliver the answer as the displacement. So, answer should be meters. Okay? Should notice that thing. Right, displacement is found out in a VT graph. In ST graph, nothing to do, no. Just look at the y-axis and deliver the answer. But in a VT graph, if you want to find out the displacement, you want to go for the area. We want to take the help from area, right? Okay. If they ask you to find out the displacement of total motion, right? The whole motion. Tell me, what is the figure has constructed here? Overall figure. Shape. Shape is what? Trapezium. If they ask the total displacement, you want to take the area of trapezium, right? So I will give you a quick example for that one. If it is 2, 10, 12, 20. Okay, right. So they ask you to find out the total displacement. Okay, we see our total motion. The shape is a trapezium. Now you want to recall how to find the area of trapezium, right? So displacement equals, total displacement equals area of trapezium. Trapezium has 2 parallel lines, parallel sides. So then same like a triangle, in a triangle, half into base into altitude. But here 2 bases are there. We want to take the sum of that. So half into base as sum of 2 parallel lines. Here what is the length in this side?
8.
8. That's why I told you write the duration. So it will be very easy for you, right? So 8 plus this side. What's it?
12.
12. So 8 plus 12, 20 into altitude. What's the height?
20.
20. So 1, 10, answer is 200. Don't write square meters. Meters, we found area, but this is not a maths question. We indirectly finding the displacement. So don't write square meters. They won't give the marks. Okay, right. Now we know our next hidden information. Displacement is found out by area of figure. Children, so you consider clearly what timeline they ask for displacement. If they ask the displacement of, now tell me, in the graph, I'm asking to find out the total displacement. So what's the shape we have to consider? Trapezium. Now I'm asking to find out the displacement traveled during first 2 seconds. Then what is the figure?
Triangle.
Triangle. Okay. Now I'm asking like this. Find the displacement of the object traveled in uniform deceleration.
2 to 10 seconds we have to take.
10 to 12.
It's also triangle. 10 to 12 area. If someone doesn't know how to clarify the shape of uniform deceleration, they will get into a trouble. No? They don't know how to identify the uniform deceleration of the VT graph. Then they don't have idea this is uniform deceleration. Then they will find something else. So all the parts I have explained here up to now is important. Okay, right. So this part, right? Now last one. What is the shape you have to consider when finding the displacement traveled at uniform velocity?
2 to 10 seconds, rectangle.
Yeah, 2 to 10, it's a rectangle or, yeah, rectangle, right? Okay, right. So I'm quickly give you another practice question, children. No, I think we don't want a practice question, but I will give you a small one. Okay. First, remember what is our pre-work? Do you need to write them? If anyone needs to note down them, please raise your hand quickly. If not, I'm erasing this. Okay, give some time to note them down. And on the other side, I will draw another practice question. I will draw a small graph and write that sub questions and note them down. Okay, quickly. You can use this as a short note. Okay. So before the exam, a day before exam, you can just go through these short notes because the basic idea is here, right? Hope you can understand uniform acceleration, uniform deceleration or retardation. Yeah, a curve indicating a VT graph is about non-uniform acceleration. Acceleration or deceleration is not uniform. I will draw that one also here. In a VT graph, mark that one. If it's like this, a curve, but it has a slope, not a downward slope, no, it's increasing. So children, that is acceleration, just acceleration, not uniform. Okay, right? And if it is a deceleration, would be like that. Okay, it's a deceleration. If you have any doubt, you can inbox. Before going to the next part, ask the doubts, okay? Unmute and ask or drop a message. Okay, children, I think enough time. Right. Quickly go to a small question. Right. These are the questions. I'll write there. First, you describe as we did in ST graph. Describe the motion. Right, acceleration. Acceleration of first 20 seconds. Third one, we'll see who will deliver the third question, answer for third question correctly. Be practical and answer that question, okay? See, deceleration of last 20 seconds. Fourth is displacement traveled in uniform velocity. However, children, before starting to write the answers, mark the durations as I told you. Okay, මෙන්න මෙහෙම mark කරගන්න. Right? Don't be lazy. These basic things are done for your wellness, right? You will have the correct answers, however. The mistakes, some careless mistakes can be happen, will be reduced by doing these things. Do the pre-works every time. Okay, take time and do it. Oh. If you have finished, you can raise the hand. Anyone need some time? Okay. Take few minutes, not few minutes. Take some seconds. Quickly finish it. When I'm introducing the symbols of these quantities at the beginning of this part, I told you one thing about deceleration. A is acceleration, and I told you something about deceleration. And recall that when writing the answer for third one, because that may affect to the marks if you got this type of a question. Okay, now right. Let's see, right? Describe. How to describe? We'll take this space. If I'm covering the board, please let me know. Okay. Describe. To describe, nothing to do, right? But you have to do first write the timelines. 0 to 20 seconds. Tell me what's happening, children. 0 to 20. This part.
Uniform acceleration.
Yes, uniform acceleration. Okay. Uniform acceleration. Right. This part.
Uniform velocity.
Uniform velocity. Then you can write 20 to 60. I'm writing short form. You write properly. Uniform velocity. Last part.
Uniform acceleration.
Uniform deceleration 60 to 80. Uniform deceleration. Okay, done it. Right. See now, second one. Acceleration of first 20 seconds. In a VT graph, acceleration finds using the formula, right? So what is our formula? A equals delta V over delta T. Okay. Now, this part is they are talking about, no, its starting point is here. Its ending point is here. Now children, see, this is a very important thing. In here it doesn't affect, but in the last part it will affect. That's why I am explaining here. Right. Ending point, what is the velocity? 100. And time is 20. So I am writing like this. 100 and 20. 100 over 20. Right. Subtracted in the starting point, nothing to do. Velocity also 0. Time also 0. Right. You will understand why I am telling this in the third question. Okay. Right. So 100 over 20. So cancel it. So finally you will get the answer 5 meters per square second. Okay. Who got this answer? Hands up. Very good. So if anyone got any mistake, please find out where you made that mistake. Okay. Right. Next, the deceleration one. Okay. So I will erase this. Okay, children. See now this one. A equals, again, we don't have a special formula for deceleration. The same thing we have to use, right? Because acceleration also, by the deceleration also gathered from the acceleration. Right. See now. Again. So deceleration happens last 20 seconds, no? Right? So from here to here. Now what is the starting point? Here, this is the starting point. This is the ending point. I told you when you write delta means a subtraction. Subtraction every time done from last and initial, right? What is the final velocity? Final velocity is 0, right? And final time is 80. Do you understand that? Huh? Hope you can understand it, okay? Final point is aligning to 0 of velocity. Its time is 80, that's all. Now starting one. Starting is what? 100. Starting velocity is 100 and its time is 60. Hope you can understand that, right? Okay, now what is the answer for the numerator? Tell me.
Minus
Tell
100.
me. Minus 100. If you don't write minus, it will be a biggest problem, right? Minus 100. If you don't write like this, sometimes you do not realize that. Next, this is okay. This is 20. Why it's minus? Because 100 has minus. 0 minus 100, no? So that's why minus. This is maths, okay? Right. Okay. Now we are going to cancel it. 5. So answer is what? Minus 5, m is minus 2. Now tell me again, what did you find? We found the acceleration. This is what? This is acceleration. But what they ask the deceleration. Then you should write, therefore, deceleration equals, without the minus, we want to deliver the answer. Do you know why? Do you know why? Because in the word deceleration, it is representing it's a minus. Because at the beginning I told you, when I am writing the quantities at the beginning of this part, I told you acceleration is A. Deceleration is minus A. So deceleration is delivering the minus 1. In the word, it is representing the minus. Then again, do we want to mention the minus here? No. And also if they ask, in the question, if they ask the acceleration, okay, in the question they ask acceleration of last 20 seconds. Okay, this is our final answer then. Okay, because they ask acceleration. So we found acceleration because in our formula, A means acceleration. So we found, okay, minus 5, m is minus 2. Correct, that's the final answer. But they ask deceleration. So first find my acceleration. And one more thing, if they ask the deceleration and when you use this formula, you got a minus value, you have a clue that your answer is correct. If you didn't get a minus value in the acceleration formula, at the end of the acceleration formula, while they are asking the deceleration, then there is a problem in your answer. Remember, if they ask the deceleration and we have only one and only acceleration formula, at the end of the calculation, you get A equals a positive value. Question is not wrong. You are the one wrong here. Okay, then you have to recheck. I didn't get a minus value, but they ask a deceleration. Then there may be a problem. So you want to recheck your answer, your process, the steps. Okay. Once you got a minus value for A, then you get the idea. Okay, my answer is okay, done, correct, minus, no. Then I want to deliver the answer according to the way they are asking from us, expecting from us. So therefore, deceleration equals, magnitude is here without minus. Do you clear that? Okay, understand? Right. If you have any doubt, please ask me. Okay? The seminar will be conducted until 1:30, but you will be given some breaks. Okay? So after the second question in your paper, you will be given a break. Please hold on. Right. So, and also remember children, try to stay until the end of the seminar because I will discuss more chemistry and physics and some bio lessons which are very important for the exam. Okay, so I have targeted the exam questions. So after this session, you will be very familiar with the most important part of the syllabus. Okay, that we will go to this. Before I am starting this one, I would like to remind you, if something is falling down under the gravity, okay, how do you know it's under the gravity? Normally, if something is falling down, not someone is taking it from here to here, or not an engine is fixed there. So then, mainly it is falling down under the gravitational force, right? Then remember, if something is moving from up to down or down to up under the gravity without any unbalanced force, there is gravitational force and its acceleration is gravitational acceleration. Tell me what is gravitational acceleration? Value?
9.8 ms minus 2.
10 depends per
10, 10, right?
9.
9.8, yes, 9.8 is the fixed value, right? So, for the calculations, we can use the rounded off value. What is that? 10, okay? Right. Notice that one as well and go through this question. Question number 2. You have the paper, no? Right? Raise your hand if you don't have the question paper right now in your hand. Is there anyone who doesn't have the paper? Hope no, right? Okay, because I want to scroll the question. However, I will keep it like this. Okay, children. Take your time and do the question. I will give you 2 minutes. Okay, children, shall we go through the discussion? Right. So what about this? The velocity time. The velocity time graph for the motion of a fruit falling from, I have included a absent detail here, fruit falling from a branch of a tree is given below. Right, so there is a tree and a branch is there. So fruit is falling down. This is the ground. That is the main thing happened there. Right, we'll see what are the things here. Even though they haven't mentioned, there are some details we want to clarify, okay? At the beginning, fruit is not moving. So at the beginning, velocity is 0. That's why this is 0, okay? And at the end, there was a velocity and we don't know that. And there was a time spent and there is a height, okay? Height means what? In our word, height means the displacement, a vertical displacement, okay? And the time is counting, the time is what? 4 seconds. And one more thing, they haven't mentioned directly, it's not in the graph, not in my diagram. What is that? What's that detail?
Gravitational acceleration.
Gravitational acceleration is there. We will take 10. If they don't ask you to take 9.8, don't take 9.8, take 10. Okay, right. Find the velocity v using the graph. Okay, v is asking. Normally in our previous practice questions, I delivered you all the details, v and t, everything. You found a. But it's okay. Now you know a, you want to find v, right? So g also, g means gravitational acceleration. After all, that's also an acceleration. So 10, right? So we can use what? In a VT graph, when you are associated with acceleration, what is the formula you are using? A equals delta V over delta T. So we can write this one. Write the, every time, try to write the formula. You get the marks for that. Okay? Alright, we'll see. A equals, right. So we know A. What is A? Right? What is A here? A is 10 equals, V is unknown, T is 4. Then answer is 10 times 4, 40 meters per second. And children, next thing, take your pencil. In exam, I mean, okay? Take your pencil and nearby write that is 40. Because you have found out the detail. No? That detail may be used, you have to use that detail. It will be useful in the future sub-questions. So update the details you are finding here. Right, that's all. Who got this answer? Quickly hands up. Raise your hand. Okay, please understand if you got any mistake, where are you mistakenly read, right? Okay.
Excuse me, teacher.
Yeah.
In that question, it's asked using the graph. Is there a way to find it using the graph?
Yeah, using the graph only we found this 4, no? Right? How did you find out 4? Using the graph. Okay? And also, how do you know it is it's exactly 10 from here to here? Because in the graph, I told you in a VT graph, if it is a uniform acceleration, same acceleration continuously going, then it is a straight line. Okay, fixed. Now we can be confirm about, yes, this motion has a fixed acceleration, a uniform acceleration, and that is 10. How do you know that one? In the description they are telling a fruit is falling from a branch. So okay, 10, right? And V is there, time is 4, all the things are gathered from the graph. Okay now? If you have any doubt, ask me. Right, second one, calculate the height from the ground to the branch. Okay, height. Don't expect every time displacement, not giving like that. You get the idea. Okay, displacement is a length of a length which is counted in meters, which has a definite direction. Height also having a definite direction, and it's also a length of a path, no? So then it's a vertical displacement. However, it is a displacement, right? Now go back to the graph. We have a VT graph, right? We have a VT graph. Now we know V, we know velocity, we know time, we know acceleration, and now they are asking a displacement. Now they are asking a displacement. Okay. In a VT graph, how to find displacement? Now we go to that short note I gave you. Okay. In a VT graph, displacement equals area of the figure, right? So what is the figure, children?
Triangle.
Triangle. So we go for a triangle, right? Right. So height, OS. You can write height as well, whatever it is, right? You can write whatever. Half into base. What is the base? What's the base? 4, right? 4 into altitude. Altitude is what? Tell me. What's the height? Altitude of the triangle? That is 40. Okay? Right. Now, what? 2 by 2, 1, 2. Answer is 80 meters. Quickly hands up those who got the correct answer. 80 meters. Right. If you have any doubt, please ask me. Right, children. Now up to here, children, we know velocity is 40, right? Time is 4. Acceleration is 10, gravitational acceleration. And height or displacement is 80. These are the details now you have up to present. Okay, we'll see this one. This question is not based on the motion in a straight line lesson. This is based on energy, work, energy, power. That's also in grade 10 syllabus. Okay, it has a few formulas. One for gravitational potential energy, other one for kinetic energy, and for power also we have another formula. Here what they ask, mass of the fruit 60 grams. What was the potential energy of the fruit when it was on the branch? Remember, try to skim the question. What is skimming? You underline the details they have provided. Also underline the quantity they ask you to find out. Okay? Right. Mass is given. Mass is given. Right? M. Potential energy. EP. Right? Okay, potential energy is EP, potential energy. Up to now, we know these details as well. Right? Okay. Now, tell me, what is the formula associated with potential energy? Who remembers that?
MGH.
MGH. EP equals MGH. So, we write that. M we know, right? M is given. G, what is G? Gravitational acceleration. We know that. H is height. We found it. By any case, if you found a wrong answer here, this answer also will be wrong. Everything is connected with each other, right? Okay, right. Now see, another important thing I want to tell you in that part, children. Remember, in a physics calculation, right? In physics calculations, we want to substitute the mass in kilograms. That's important and that's compulsory, right? Mass in physics calculations should be substituted in the formulas in kilograms, right? But in chemistry calculations, when you are substituting the mass values, it is okay to be in grams. Not okay to be, it should be grams. In chemistry calculations, the formulas are substituted, the mass values are substituted into the formulas in grams. In physics calculations, it's in kilograms. Okay, remember that. Okay. If you forget that one, please note down that. Okay, right. M. Now this is a physics calculation, no? It's given in grams, no? So we want to convert that into kilograms. Don't do take a separate paper and 60 over 1000, 0.006. Not like that. Okay. So you take it like this. At the same place, convert that into kilograms, children. Now you know grams are converted into kilograms by divided by 1000. 60 divided by 1000. Write like that because we have several 10 multiple values are there. You can cancel and easily find the answer. Don't take the decimal answers here. You will make mistakes. Okay, G is 10, H is 80. Okay, right. Now see, cancelling them. Oh, very easy. If you are taking 0.006, that will be a problem, right? Because most of children are confusing when they are having decimal answers to multiply and divide. So avoid that weak points. 6 into 8, 48. What is it? Tell me what's the measuring unit, please. Quickly.
Joules.
Joules. Whatever energy. Heat or magneto, chemical or kinetic or potential or electricity or whatever. If it is an energy, joules. Okay. Quickly raise your hand who got the correct answer. Very good. Very good. Right. We will go to the final question. I will draw the displacement. I will draw the graph here. They are sketched the displacement time graph for the motion mentioned above. That is a very usual one. Sometimes they will give you a displacement time graph, ask the velocity time graph. Sometimes VT graph is given, its ST graph is asking. Here now ST graph should be drawn. Right. Now, when you are switched into drawing a ST graph, you have to change your state of mind about analyzing the displacement only the displacement. Okay, right. Now again we are going to have a short note of ST graph. If you have noted down, you can look at that one. In ST graph, the shapes are based on what quantity? What? In VT graph, shapes are based on acceleration. In ST graph,
Velocity.
velocity. Now you want to train your mind. Okay, what is the velocity of the motion? Go back to the motion. Right? This is the motion. What happens to velocity, children? Velocity has increased, no? From 0 to 40, it has increased. But with uniform acceleration. Acceleration is there, right? And velocity increases. Velocity increases and also what happens to the displacement? First mark them. First mark them S within brackets M, T within brackets S, and 0. All the basic things are there. Right now you are going to draw the ST graph. Okay, what happens to displacement? Displacement increases. No? At the branch 0 meters. At the ground 80 meters. Okay, so 80 will be there. Don't want to mark 1 to 80. Some are doing that as well. Okay, so 80, right? Okay, so velocity increases, right? Acceleration. Now, if you have your short note I have given you, please go back to there and see how did we represent acceleration in ST graph. How did we explain that? What type of a shape? Is it a straight line or a curve?
Teacher, acceleration or velocity?
Yeah, acceleration means increase in velocity. Now here velocity increases, no? Right? At the branch 0 velocity, but at the end 40. It has become 40. Right? So then acceleration is there. Velocity increases. Right? So acceleration was like this, no? In ST graph, see in your short note, I told you to note down. Right? In ST graph, acceleration was like that. Deceleration was like that. But here not deceleration, it's acceleration. 10 ms minus 2 acceleration done. So it should be like this and have to Point out like that. What's the time, children?
10:54.
Time? Time, we know
Excuse
that.
me, teacher.
4 seconds.
4, right? Okay, yeah, 4. Same motion, no? Time is not changing, okay? 4 seconds. Is it clear? Now, can you see the board? Okay. Is it enough?
Teacher,
Yes.
they've asked the final velocity of the foot, right? Fourth question.
Final,
Can you
yeah.
answer?
Did I miss anything?
Yeah, teacher. Enough?
Yeah. Sorry. Okay. We wrote that one here now. Okay. Final velocity, children. Thank you for telling me. Final velocity. Is there anything to do, children? Is there anything to do? I want to tell you that. Final velocity. What was the final velocity? What is it? V, no? That's the final velocity. When it comes to the ground, that's the final velocity. They ask in 2 ways, then you will think, you will confuse, and you will think, there is something else. No, not something else. But that's the answer. Same answer comes to here. Just to mislead like that. Okay? So, answer for this one is 40 ms minus 1. Same answer asking in 2 different ways. So when you practically think about that one, they are telling about our first answer. Okay? Hope the other students can see the board. Okay, some have put the messages that they can't see the board. Okay. Right, children. Now, we have some other more important questions to discuss, right? Those are theoretical parts and some chemical reaction based on what. So, I expect you to continue this after a little break. So, take 20 minutes break and come at sharp 11:20. Okay? So, come on time because we have some other important parts to discuss. Okay, take a break and come back. Okay, we are going to start now.
Okay, we
Okay,
will
we will
start
start
again,
again,
children.
children. Okay, here again we have a chemistry question. Quickly, we will go through this one. First, I would like to, I hope you can hear me, right? So now we are going to go through some background points of this part. If you see this one, you can understand. If you are familiar with the section, we can understand, you will be able to understand. This is about the extraction of iron. Okay? Right. Now, right. So what are about extraction of iron? So in there, children, we have to recall some important facts about the extraction of iron. So first I will go through quickly about that. Okay, for this we are using a special setup which is called blast furnace, right? So that diagram, that setup is what they have given in the question. This is the setup. So it has a special wall which is called fire brick wall, because to do this process inside the setup we have to supply a large amount of heat. So then more heat will come out of the setup. So to be resist to that amount of large temperature, they have made this brick that much of a thick, and it is heat resistant wall. So that's what we call fire brick wall. Okay. And first I would like to show you that the appearance, the structure of this one, you can see from the upper side of the setup, they insert all the raw materials, right? And then from down, there are two opens. You can see from here, one open, another open, same level open. So that's what, from this open, the extracted iron comes out, our main output, okay, main product. And here also it has another open, you can see it, right? From that only the slag comes out. Now we will consider what are those things, okay, right? Now please listen carefully. This is very important. So when some children are looking at the setup and they don't familiar with that one, so they skip the question. You can skip the question if that is in the essay part. But if it is in a structured part, or if it is in a MCQ one, you can't skip the question also. Try to understand the fact. Okay, right. First, when you go through that one, first thing happens is the raw materials. So what are the raw materials we have to use for the extraction of iron? So there are three raw materials, children. First one is hematite. In there, special thing you want to remember, hematite is a sample of soil, right? It's a mineral soil, and the hematite mainly abundantly contains ferric oxide. What is it? Ferric oxide abundantly contains ferric oxide. And next it has some two other materials that are called, these substances are called silica and alumina. That means silicon dioxide and aluminium oxide. Those are the things contains there, right, in hematite. Right. So what is the thing we need for our process is ferric oxide. But we can't separate them. We have to take only for ferric oxide. We don't need silica and alumina. Like that, we can't clearly separate them. right? We have to take the hematite sample. It abundantly contains ferric oxide, and then in small amounts silica and alumina is there. Okay, we have another method to separate them as well at the intermediate steps of the process. Okay, next one is another raw material we use. It is coke. What is coke? Tell me, what is coke?
Carbon.
Carbon. Very good. Okay, right. Third we need, who remembers the third raw material? Tell me.
Calcium
Limestone.
carbonate.
Calcium carbonate, or we call it limestone. Okay, in Sinhala we call hunugal kiyanne, right? That's what, calcium carbonate. Okay, right. So these are the raw materials we have to use for that one. And so we insert the raw materials from here. From here, raw materials are inserted, right? From here, the raw materials are inserted there, right? Next, we go for the main things, right? Now, what happens first and next, and what are the intermediate steps? We have to describe that using the chemical reactions. So, all together, there are some main chemical reactions, children, which are related to this, right? First chemical reaction is, first now we supply coke, no, that is carbon, right? The most special thing about this is, how do we extract iron? How do you obtain iron from the ferric oxide? We have to break the bond. We have to break the bond of ferric oxide and have to extract iron. Who can do this? This task can be done by carbon monoxide, right? Then we don't take carbon dioxide from outside. We have to supply all the things to the setup in the manner carbon monoxide are produced inside the process. During the process, carbon dioxide is producing inside the setup. That carbon dioxide breaks the bond between iron and oxygen to extract iron from the bond. Okay, that's the thing. Then our first task is breaking the bond using carbon monoxide. Then for that one, first thing we want to do is producing carbon monoxide inside the setup. How do you do this one? Okay, right. So first thing we are doing for this is what? First we are taking carbon. Carbon is there now, coke. So carbon first heats, combusted. The combustion of carbon inside the setup. I couldn't tell you that one. Here I told you there is an open. Two opens are there, right? From first open, in the right side open, hot air is supplied. Hot air is supplied, right? Hot air is supplied into the setup. Because of this hot air, what is happening? The coke which is inside the setup, supplied to the setup, is combusting, right? They are burning in air. Then in chemistry, if something is if the combustion reaction in chemistry is mainly delivered by a reaction with oxygen. If anything is combusting, that means that substance is chemically reacting with oxygen. So, which is burning in air? Coke. Coke means carbon. So, carbon is burning in hot air. That means in our chemistry term, we take it as a chemical reaction with oxygen. So, carbon chemically react with oxygen and produce carbon dioxide. Okay, so first I am writing like this way. Later we will consider how do you balance the chemical reaction. First we will write one by one. Okay, first reaction happens here is producing carbon monoxide. Still we couldn't produce carbon monoxide. Now we have at the beginning carbon is supplied through coke, and coke is burning in hot air. That means carbon reacting with oxygen gas and producing carbon dioxide. Okay, now next one is carbon dioxide is there. No? This carbon dioxide is there. And also we continuously supply coke. So continuously carbon is supplied. So with this produced carbon dioxide, now new carbon is also chemically react. Then carbon monoxide is present. This is our main role. Now we have produced our main role, right? May වැඩේ main role like a carbon monoxide. ඔන්න දැන් ඒක හැදුනා, right? Now it is produced, right? Now this is like hero. He only can break the bond of ferric oxide and give us iron, extracted iron. Okay, right. Now our third one. Once the carbon monoxide starts to produce one by one carbon monoxide molecule go to one by one ferric oxide molecule and break their bond individually. Then what will happen? Ferric oxide right here. And now what will happen? Ferric oxide react with carbon monoxide, and what will happen? What will happen? Iron is extracted, and as a byproduct, carbon dioxide is produced. Okay, that's what happening in here, right? Okay, now our main task is completed. Now we think our process is done. Okay, our task is done. No, it's not done. Our main target is fulfilled, but we have some other fact have to consider about that one. Now, children, we have used ferric oxide, coke and everything, but we didn't use limestone, right? Why then we use that one? I told you the task is still not completed. Then how our task is completed? Now, children, you forgot hematite only we applied, right? So ferric oxide did its work, right? What about silica and alumina? එයාලා නිකන් ඉන්නේ, they don't stay like that, okay? Now they try to attract iron. දැන් මේ extracted iron එක තියෙනවනේ. So then silica and alumina try to attract that extracted iron and chemically react with them, right? So they are trying to do that one. How do you prevent that? If again silica and alumina reacted with iron molecules, iron atoms, what will happen? Again we have to find some another way to extract iron from them as well. Then we want to prevent happen that. For that one we use limestone. Limestone or calcium carbonate can't do that one directly, right? But it can be done by calcium oxide, right? And then first we want to produce calcium oxide inside the setup. For that one we use calcium carbonate. So what happens to calcium carbonate? Calcium carbonate also supplied that hot air, no? That's also combusting. That's also burning in hot air, and they are decomposing. That is called thermal decomposition reaction. What happens here is, see, calcium carbonate undergoes with thermal decomposition. That means in hot air they burns and separated. How it happens? Into calcium oxide and carbon dioxide. That's what happens here. Okay, right. Now calcium oxide is there, and now calcium oxide is the security guard here. That is the one who protect iron from silica and alumina. Okay, once the calcium oxide is produced, what will happen? This calcium oxide will react with silica and alumina, because now silica and alumina is trying to attract towards the iron. No? So before that one, calcium oxide comes to there, interrupt there and attract silica and alumina towards itself, right? Okay, එතකොට මොනවාද වෙන්නේ? So silica is silicon dioxide. And they converted into calcium silicate. Okay, and next one, I will write that one again after erasing the board. And also calcium oxide react with aluminium dioxide and produce calcium aluminate. Okay, that is what we called slag. Slag is an unknown thing, right? So normally children, if you go back to this one, I told you slag comes out from here. The iron comes out from here. Slag comes out from here. Extracted iron comes out from here. Now my children, remember, because of the difference of density of iron and that slag, right? Slag will floats on the extracted iron, right? And also in that period, remember, it has a higher heat inside that one. It's more than the melting point of the iron as well. So normally our output, extracted iron, comes in liquid state. So we call it as molten iron. Remember that. Okay. So iron comes in liquid state. Okay. Right. So then there is liquid iron. Okay. Liquid iron is there. On that one, slag floats. Like coconut oil floats on water. Okay. Right. So then slag comes out from here. Molten iron comes from here. So that's what mainly happening there. Okay. So these are the main examples. So again, I will write all the reactions. You can write these reactions. Before that one, you can quickly note down these raw materials, right? And after that, we will write the chemical reactions. As this is very important, please note them down if you are not familiar with that one. So take this as a short note of the extraction of iron. At least a single question would come with this lesson. Okay, that's why I choose this. Okay, Shaka. We'll quickly go back to that one. So quickly we'll write the main chemical reactions. I will write the main chemical reactions as I mentioned before, and you try to balance by yourself. I will give you 1 minute for that. Okay. Quickly go through that. So what happens first? Carbon is burning in hot air, so produce carbon dioxide. And then what happens? Again, that coke react with carbon dioxide. Furthermore, and producing our main role, carbon monoxide. And then, okay, now our main role has come. Then now our ferric oxide reacts with carbon monoxide and our main task is completed there, plus CO2. Right? And then our protection part. Another hero comes for that one to protect iron from silica and alumina. Okay? Right. So what happens? That intermediate one is calcium carbonate undergoes thermal decomposition, calcium oxide plus carbon dioxide. Now this is our second hero who protects iron from silica and alumina. Like a story, please remember that. So don't want to memorize again. Right, so what happens there? So calcium oxide reacts with silicon. Just we will write about alumina. This is what we call slag. Quickly write down. This is what slag. Their names are calcium aluminate, calcium silicate. Okay? Calcium aluminate. Normally they don't expect this one, but you better to memorize the formula. There are 3 atoms now, so using valencies it's a little bit difficult to identify. So, but you see calcium, 1 calcium, 2 aluminiums and altogether 4 oxygens. That's how it is arranging. In here also 1 calcium, 1 silicon, 3 oxygens. That's how it is arranging. So, nothing more to remember. Other all can be clarified by the chemical formula constructions. Okay, right. Now I want you to do, children, please quickly go through that one and balance the chemical reactions. You don't want to balance these 2 chemical reactions already balanced. Other 2 please consider and try to balance them quickly. Hansaka asking gas preparation කරනවද hydrogen gas ඒ කියන්නේ අද seminar එකේ part එක කරනවද කියලාද අහන්නේ නැත්නම් මෙතන gas hydrogen gas preparation එකක් වෙනවද කියලාද අහන්නේ. අද මම gas preparation part එකක් කරන්න හිතාගෙන ඉන්නවා. අපි මේ පේප් එක ඉවර වෙලා තියෙන time එක කොහොමද කියලා බලලා මම කරන්නම්. අද ඒක බැරි වුණොත් අනිවාර්යයෙන්ම හෙට session එකේ teacher ඔයාලට අනිවාර්යයෙන්ම ඒක කරනවා. ඒ නිසා ඒ ප්‍රශ්න කරගන්න එපා. අනිවාර්යෙන් gas preparation part එක වැදගත්. hydrogen, oxygen and carbon dioxide ටික. Okay. Right children බලන්නකෝ කොහොමද අපි මේක how do you balance it? There is nothing to balance, children. Left hand side 1 carbon, here also 1 carbon. Here left hand side reactants has 2 oxygens, here also 2 oxygens. Nothing to balance, okay? In second one, 2 carbons are here, but only 1 carbon is here. How to balance it, children? What to do here? අපි මෙතනට 2 දැම්මනම් හරි නේද? Right? So if it is 2, it's affected by this as well, no? So 2 oxygens, here also 2 oxygens, 2 carbon, altogether 2 carbons, okay. Here what we have to do here? So there are 2 ions. බලමු අපි මෙතනට ion වලට දෙකක් දාලා 2 දැම්මොත් මොකද වෙන්නේ? How many are there then altogether? 1 carbon, 3 oxygens. So, කොහොමද ඒක balance කරන්නේ? Is it correct? Can we balance like this way? පුළුවන්ද මෙහෙම කරන්න? දැන් සාමාන්‍යයෙන් first site එකේ ඔයාලා කරන දේ මම මේ කරන්නේ. අනිත් Fe2 දෙයා then මම iron එක 2 කරනවා. හැබැයි ඒකෙන් අනිත් එක balance වෙන්නේ නැහැ. Then tell me how did you do that one? Someone please unmute and tell me how to do this.
Fe2O3 plus 3CO is to Fe plus 3CO2.
3CO2 අන්න බලන්න අපු විදිය. Right? Is it correct? One all together. දැන් අර මම ලිව්වම Fe2 ආය අපි හිතුව නෑ. මේක එන්න බෑ. So then ආය අපි බැලුවාම we can see okay carbon and oxygen can be balanced here. මොකද මෙතන ප්‍රශ්නේ තියෙන්නේ Fe වල විතරයිනේ. So we can balance Fe. Nothing to do here. So you can see all together 3 carbons are there, 3 carbons are there. All together how many? 6 oxygens are there. මෙතන 3යි මෙතන 3යි and there are 3 into 2 6. Okay, very good. Right. Then here, is there anything to do? Only 1 calcium, 1 calcium. 3 oxygens, 1, 2, 3 oxygens, 1 carbon. Nothing to balance. Okay, right. So quickly I will write down the physical state. That's also important for you. Sometimes in marking scheme, they don't strictly expect the physical states. But you better to write the physical states. Sometimes they in questions they ask no what is the physical state of calcium oxide produced inside the blast furnace. So it is solid. Better to remember with that one. So coke, solid, oxygen definitely a gas, carbon dioxide is a gas. Okay. Again coke, S, gas, gas. Carbon monoxide is a gas. Here, ferric oxide, definitely solid. Gas. What is this? What's the physical state?
Liquid.
Liquid. I told you, because of the high heat inside the blast furnace, definitely the output is a liquid and this is a gas, children. Okay, this one again, solid, gas. These are doesn't form, but you can write solid. This like reaction, they don't expect the physical state, but better to remember that is also solids because it's in hematite. They both are liquids. Remember. That's how it's coming in the slag. It floats on the molten iron and comes out. Okay, children. Right. These are the things. Right. As the iron at the middle of the activity series. Right. If you remember the activity series, I will try to manage the time to explain about that as well. First 3 and 4 metals in the activity series, they have high reactivity. So then if you want to separate them, extract these metals, we want to use electricity. So electrolysis process. When you go to the middle ones, iron, copper, zinc, likewise, they are enough to undergo the oxidation process. Someone has to come and break the bond. That's the thing. Do not need electricity every time. It's not compulsory to use the electrolysis process. When you go to the lower reactive metals, physical methods are enough to separate them, extract them. So note them down everything. So I hope you have noted them down these as well. We'll go back to our question and quickly write the answers for that one, please. Quickly answer these questions. Okay, shall we do together? Right, we can save the time. Name the raw materials used here. Tell me quickly.
Coke, hematite, and limestone.
Coke, hematite and limestone. Okay, coke, hematite, limestones. Right. What is the physical state of iron comes out from the setup? Easy. What is it? Liquid. Molten iron. Okay. Write the major balanced chemical equation of this process. What is it?
Fe2O3 plus 3CO becomes 2Fe plus 3CO2.
Yeah, that one. Because we had so many reactions, but major one is what? The main role. Okay. What is it? Fe2O3 solid plus carbon monoxide gas into iron liquid plus carbon dioxide gas. So again have to balance it. How did you balance? 3, 2, 3. Okay. Right. What are the main components of slag?
Silica
Tell me
and
that.
alumina.
Silica and alumina is wrong. Okay.
Calcium
That's wrong to
ammonium and calcium silicate.
Calcium silicate.
Yes, very good. Calcium silicate and
Calcium
calcium
aluminum.
aluminum. If you don't remember the formula, I recommend you to write in the word. That's okay because slag no, so I told you they sharply don't expect that one. But for other, it is very important to remember by the formula, right? So calcium silicate, okay, not silica, and calcium aluminate. Don't write hybrid words, okay, like calcium in Ca, anith එක word එක. Don't write like that, okay, either full of the word or the formula, right? Write the type of chemical reaction taken place in limestone. So that one, what is it? Calcium
Thermal
carbonate plus then කලින් ලිව්වා කියලා ලියන්න නැතුව ඉන්න එපා. Write again, then you can memorize again, okay? It's undergo thermal decomposition, calcium oxide plus carbon dioxide. Do you want to balance it? Nothing to balance. Okay, children, that's all. We will quickly go to the next question. Okay, another chemistry question. So as you right, for a while we will okay, quickly finish this one. Right, this is about what? This is about chemical reactions again. Quickly go through that one and we will enter to the essay question. It has some other physics and bio questions as well. Okay, right. See this one. The following activity is done to find out the nature of the reactivity of aluminium, magnesium, zinc and silver with equal volumes of copper sulfate solution. Okay, right. I told you reactivity is needed for that one, right? I give you some time to go through the questions and write answers quickly. And please note that for this one, the main resource you need is the reactivity series, activity series of metals. Try to memorize that, recall it, and try to write the answers for that one. I will give you 1 minute. Okay, shall we go through the activity series, children? Who remembers the activity series? See. Potassium, calcium, potassium, sodium, here all the metals no, but interrupted by a gas. What is it?
Hydrogen.
Hydrogen. So you can take it as a termination. මේකට H වෙනකම් මතක තියාගත්තා ඉතුරු ටික ආයෙ මතක තියාගත්තා. Like that you can use it. Okay? Hydrogen. After that what?
Copper.
Copper. Copper. And
Mercury.
Mercury, right? Copper, mercury. Remember, before hydrogen, what are the things? After hydrogen, what are the things? Okay? Mercury, copper. What next?
Silver, platinum, gold.
Yes, silver, platinum, gold. Hope you can clear it. Okay? Right. Okay, children, we'll see. These are the test tubes. Okay? Right? Every test tube has copper sulfate. Same solution, but the metal they have used in the copper sulfate is different. Aluminium, magnesium, zinc, silver. Right? Okay. Now, if all these are having copper sulfate, now we want to compare the relationship between the metal in the solution and the metal we are adding outside. Okay, right. So copper is the metal in the solution. Then other aluminium. Then we want to consider what is the relationship between aluminium and copper. Relationship means their comparison of their reactivity. Who is more reactive? Who is less reactive? Okay, copper, aluminium, copper, magnesium, copper, zinc, copper, silver. That's the thing, right? Okay. What is the color of copper sulfate solution? First one is a general knowledge in chemistry. What is it? Blue color, right? Normally children, copper sulfate is a powder or crystals, right? Those are in white color. But if it is connected with, subjected with water, suddenly it becomes blue color, right? So when you prepare a solution, you want to dissolve copper sulfate white color powder in water. So it gradually turns into blue color. So what's the word? Blue is the color. Name a test tube in which a chemical reaction could be observed. A test tube means there are more than one. You can write one of it. Tell me. How do you identify? Yeah. Any answers?
A, B, C.
Yeah, you can write A or B or C. Why? Why? Because when you compare copper, we are going to compare now, right? Copper is here, no? Right? And our other ones are who? Aluminium, magnesium, zinc, and silver, right? Aluminium, magnesium, zinc, all these are in the upper level of the copper. That means they are more active than the copper, right? Then definitely these three elements, these three atoms can replace to the place of copper sulfate. They can come to the place of copper sulfate. How? Because they are more active, they are stronger, they can take copper out from the compound and come to the place of it. Right? So then the reaction can be occurred only in A, B and C. Right? They are asking only one. You can write either A, B or C. What about D, children? Tell me what is happening to D? Can we see anything in D?
No reaction.
No reaction.
Nothing happens. No matter how many times you are looking at that one, still the silver metal particle will be inside the copper sulfate solution. Nothing happens because Silver doesn't have strength to remove copper from the sulfate solution, right? So because it is less reactive. Okay. Write the balanced chemical equation in test tube A. Right, test tube A has aluminium, right? So aluminium plus what? What is the other one? What's the other
CuSO4.
one? Copper sulfate into, now what is happening?
AlSO4.
Breaking the bond, yeah, taking the copper out, aluminium comes to there. Then if you writing like this, am I correct?
Cu.
Cu comes, yeah, Cu will be isolated, it will be alone. Now I am asking, is this one correct? Is this formula correct? Is it correct? Wrong, why? Why?
Valency.
We have to consider the valencies, no? So we can't just write aluminium comes to here and sulfate, that's all. Not like that. Then what's happening to the things we have learned from the morning? I told you when you are writing a chemical formula, you want to consider about their valencies. Go back to that one. Aluminium 283 because it's 13th. No, then valency is what? What's the valency of aluminium?
3.
3, okay? And now sulfate, we don't get sulfur and oxygen separately. It is a polyatomic ion, children. Sulfate. So, SO4 2 minus. Why we take this on polyatomic ion has a charge. If you don't and if you can't remember the correct charge there, you will mistakenly take another unnecessary valency because charge is representing the valency of polyatomic ion because it doesn't have electronic configuration. We can't write that. It's not a single atom. Then 2 is the valency. Then changing it, how it's coming? Aluminium takes 2, sulfate takes 3. Like in maths, these three belong by the set of the atoms in polyatomic ion. So we want to put a bracket. And do we write the charge there? No, charge will be disappeared once the polyatomic ion is combined in a chemical bond. These are the most important things. Again, I am reminding you after the session, please take some time to revise the third unit of grade 10 first part book and practice some chemical formula. They have given lot of names of chemical compounds. Okay, right. So answer is this. Now you can understand, even though you are very well expert in the lesson, if you don't have idea to write the chemical formula, what will happen to this reaction? The whole one is wrong. Okay, right. So then they ask you to balance the chemical reaction. How to balance it? Tell me. How to balance it? You can make this 2 because 2 aluminiums are there, right? 3 sulfates are there, but in this side it has only 1 sulfate. So put 3 because of that one number of copper changes. Can write copper 3 here. Hope you can understand. Okay. Right. To which type of chemical reaction does it belong?
Single displacement.
Single displacement. Why? One atom comes to the place of other one. Okay. Right. Now, single displacement. Okay, now up to now I am waiting for someone who is correcting a mistake here. There is a small mistake. Did anyone notice that? You see if someone has
CuSO4 should come
put that in
front.
inbox. One of you has put an inbox message. Yeah. What is it? In the activity series. What is that? So normally it's very common to make confusion in the order, right? So that's why I told you before the hydrogen take the correct order, after the hydrogen correct the other order. You separately memorize them. Okay, so remember which comes after hydrogen.
SN.
After hydrogen, mercury. Mercury comes after hydrogen. I thought දැන් කියයි කියලා බැලුවා නෑ. Okay, right? So and also the another common mistake you make is platinum and gold. Here correct. I mean some are thinking the platinum is at the end of that one. There is a small confusion. No, gold is at the end. Okay, silver, platinum, gold. Right? Okay. Now quickly write down them and name the test tube in which a chemical reaction couldn't be observed. Give reasons. Where we cannot observe the chemical reaction, children. මුකුත් බලා ගන්න බැරි මොකේද?
D.
Here, why it is? Because silver is less reactive than copper. Right. So, chemical reaction couldn't be observed. Give reasons. Test tube D. Right. What is the reason? Because silver is less reactive than copper. So hereafter, if you got this type of a question every time, try to memorize and recall and use the activity series. That's the main resource. Okay? And compare the metals. Okay. If I ask you one more question based on that one, how do you know a chemical reaction is happening in the first 3 test tubes? Now you say A, B and C. In test tube A, B and C, chemical reaction happens. How do you know that one? Practically, how do you know
Because
that
the
one?
metals are placed above copper in the activity series. So they are more reactive. So they are powerful enough to displace copper.
Yeah, that's what happening actually. But can we see aluminium comes and can we see that? We can't see that now. How do you see it practically? Test tube how do you see that one, children?
Color changes.
Color change.
Very, very good. Color change. Because at the beginning they asked what's the color of copper sulfate. Copper sulfate is a nice blue color, right? So once any element is coming and removing copper and coming its place, one by one copper sulfate molecule is converting into another metallic sulfate. Then there can be any blue color afterwards. No, you can see gradually blue color is faded away. And after the complete reaction, after a considerable time, the whole blue color has faded away and it has become colorless or any other color, right? Because copper sulfate is no more there, right? That's a good answer. And also that type of questions are usually asking. Okay, quickly we will go to essay questions. Okay, here. I think fed up chemistry, physics. Now we have come to a bio lesson. This diagram, this question was a good question from a past paper. I took that diagram here, but I have changed the sub questions of that one. Okay, I took this one just to give the clear idea about if you memorize the body systems, right, and just katapadam karagena yana, memorize the body system and go to the exam, that's not the only help you can get from there, right? You want to understand the structure, the process, like a story every time, try to understand it. Then whatever the diagram they are delivering us, you can answer any type of question. This is one of a good example for that one. Heart එක කොහමද අපි ඉගෙන ගන්නේ? මේක totally වෙනස්. හරිද? But if you understand the facts of the circulation, When by looking at that one, you can demonstrate it. Substitute, that one is here, this one is here, like that. Okay. Before entering into this question, I would like to tell you some important parts of the heart, human heart. Okay, quickly we'll go to that one, children. Heart එක කොහොමද? So normally heart is in the left side. Okay, මෙතන තමයි heart එක තියෙන left hand side. Okay, so then heart is little bit inclined to this side, to right hand side. පොඩක් incline වෙලා තියෙන්නේ, right? එතකොට heart එක මෙන්න මෙහෙම තමයි තියෙන්නේ. Right? Okay. So, and then next thing is the walls of the heart. Different. Now, normally as the mammalians, we have 4 chambers of heart. First, the heart is divided into 2 segments as the oxygenated blood and deoxygenated blood. What are oxygenated blood? It contains high concentration of oxygen. Deoxygenated blood contains low concentration of oxygen, high concentration of carbon dioxide, right? Okay, so these 2 sides are separated by that one. Normally, this whole side has the oxygenated blood, this whole side has the deoxygenated blood. Remember that, okay? Right. Now, the chambers. Upper chambers are called, what is the word?
Atria.
Yes, upper chambers are called atriums, lower chambers are called ventricles. Now, there are 2 atriums, 2 ventricles. Now, how do you distinguish them as left ventricle, right ventricle, left atrium, right atrium? Tell me which number belongs to right atrium?
1.
1. Right? Mehema balala, this is right, this is left. Totally wrong. This is a body organ. Right? If you fix that into your heart, this is your right side, this is your left side. So if you want to consider in a body organ, if you want to consider the right and left hand side, cross your hands. And where are your actual left hand side going? That's the left side. Where your actual right hand side is going? That's the actual right side of the organ. Remember that. Please remember. Okay? Right. Okay. These are the things. Sorry. Right, children. Quickly we will draw their blood vessels. First I am going to the first blood vessel, children. That's aorta or systematic artery. It's starting from the left ventricle and going like this and separated into several semi-arteries and going back. Going back කියන්නේ heart එක පිටිපස්සට ගිහිල්ලා it's going to several organs, every organs, right? So that's how it's coming. Right? Okay. Right. Now, however, this is the thing. Right. Next, we are going to draw another one. I will use blue, which is starting from here. What is done by the systematic artery or the aorta? Aorta supply oxygenated blood, newly pumped oxygenated blood to every organ. Okay, from the heart, right? So, and also children, this aorta is starting from the left ventricle and it is newly pumped oxygenated blood. Newly pumped oxygenated blood has a high blood pressure. It has a high blood pressure. So then aorta should have with a proper thickness of the walls to bear the pressure. Right? So then it has to be with the proper thickness of the walls. So aorta has a good thickness in the walls to bear that pressure. Okay, now next one. Next artery is starting from the right ventricle. Right ventricle. So that is called pulmonary artery. That is called pulmonary artery. Tell me, this artery is going to where?
Lungs.
Lungs.
Lungs වලට යන්නේ. ළමයි, lungs associated means, okay, pulmonary. Pulmonary word is using because the lungs are associated with that one. Remember like that, okay? Then you will not be confused about the names, okay? Right. Pulmonary artery is taking deoxygenated blood to lungs. Why? Because once the heart is collected the deoxygenated blood from the organs, this should be purified, no? Right? To purify it, it has to taken into the lungs. මොකද lungs තමයි මේවා purify කරලා දෙන්නේ, because lungs have the, alveoli, they have the oxygen and carbon dioxide. Then the blood is carried out to the lungs and lungs okay ඔයාට oxygen මදිද කියලා දෙනවා. Carbon dioxide ටික ගන්නවා. That's the thing happening there. Okay, pulmonary artery divided into two main arterioles and coming to each lung. Okay, right. What is the next thing? Next, I told you, now once these lungs are almost purified the blood. Then purify කරපු blood ටික heart එකට ගේන්නේ කොහොමද? That purified blood is taken to the heart by, again, pulmonary word එක ගන්නවා. Why? Lungs associated ne? So then lungs are giving the purified oxygenated blood to the heart. It is carried by 4 veins, right? 4 veins. 2 from left lung, 2 from right lung. Altogether 4 comes, right? Those are called pulmonary veins. ඇයි ඒවට veins කියන්නේ? Remember, artery එකක් නම්, if it is an artery, okay, if it is an artery, arteries are type of blood vessels every time taking blood out from the heart. Okay, arteries are coming out from heart. Out from heart. Okay, veins are blood vessels which are coming to heart. කොහේ හරි ඉඳන් heart එකට එනවා. Coming to heart. Into heart. Remember that. Then because some children are misunderstanding artery nang it has pure blood. Right? Veins nang it has non-pure blood. It's a wrong fact. Okay, remember, artery means going out from the heart going outside. Veins are coming to the heart. Okay, as these blood vessels are coming to heart, it's a vein, and as it is coming from a lung, pulmonary veins. Okay, on the lungs තියනවා. Okay, lungs වලට තමයි මෙයා යන්නේ, and we are taking another one. lungs වල ඉඳන් 2 එනවා මෙහෙට, දෙකක් එනවා, and another අනිත් දෙකත් යන්නේ මෙතනටමයි. Right? So all are coming to here, and here. Pulmonary veins. Okay? Right. The final one is, now the children, this aorta brings oxygenated blood to other organs. Now every organ is doing biochemical reactions inside the organ. So many reactions are happened inside that one. Because of the reactions happens in each and every organ of the body, carbon dioxide is produced as a byproduct. Right? So there will be a collection of blood which has higher carbon dioxide concentration. While the new pure blood is supplied to that organ, that collected non-pure blood should be taken out from the organ as well to purify it again. Right? So then it is done by 2 veins. What are those? Tell me.
superior, inferior vena cava.
Yes, superior and inferior vena cava. Inferior and superior vena cava. Tell me. Okay. They are joining to what? Our right atrium, children. Okay? Right. This is a inferior vena cava. Upper one or lower one? Yeah, right? So inferior and superior vena cavas, right? So they are coming from the inferior part of the body and superior part of the body, right? Upper organs from the neck and lower organs from the neck. That's how inferior and superior. Superior vena cava, inferior vena cava, right? Right. Okay. So these are the main things. As these are coming to heart, they're called veins. And they contains non-pure blood, deoxygenated blood. Okay. Right. Now children, them are blue color king. The things I have drawn in blue color, they contains deoxygenated blood. The things I have drawn in orange and red shades, those are oxygenated blood. Okay. Then අපි බලමු to demonstrate these two together, right? Okay, see, lungs are here, other body organs are there. They tell, indicate below is a diagram drawn to depict double circulation of blood in humans. A, B, C and D are indicating chambers of heart, while P, Q, R and S indicate the blood vessels connected to the heart. Okay, now tell me children, before we are going to the questions, we will clarify what are P. Tell me what is P. Don't go to the path. You see it is fixed to which chamber?
Superior
P is what?
inferior vena cava.
Yes, inferior and superior vena cava they are telling about. Okay? Inferior and superior vena cava. Right. What about Q?
Pulmonary veins.
Pulmonary vein. See? Lungs වලින් ඉඳන් එනවා. Coming to the lungs. Pulmonary veins. R is what?
Pulmonary artery.
Pulmonary artery. Final one is D. It's coming out to the heart, out from the heart to other body organs and starting from the left ventricle, and that is
Aorta.
S is, yes, aorta, or another word, systematic artery. Okay, children. Very good. We'll go to the next one. What is called double circulation? It is a very important part. Double circulation means you can see in the circulation part, when the blood goes through the body one time, how many times meanwhile the blood going through the heart? 2 times. Because the pulmonary artery and the aorta, right? That's the double circulation. So how do you answer that one? When blood goes through the body once, blood goes through heart twice at the same time. That's how to write it. Okay? When blood goes through the body once, blood goes through the heart twice. That's a simple idea. Okay? Right. Now see, the vessel Q represents more than one blood vessel. How many blood vessels are represented by it? I told that. What is it? Vessel Q is pulmonary veins. Now we have clarified it. Now very easy to answer the questions. The vessel Q represents more than one blood vessel. How many blood vessels represented by it? Quickly tell me how many?
4.
4. 4 is the answer. Very good. Right. We'll go to the next one. Write the difference between the blood vessel R and S. R and S. R is a pulmonary artery. S is aorta.
R has deoxygenated blood while S has oxygenated blood.
Very good. R has deoxygenated blood while S has oxygenated blood. Now once you got this type of a letter-wise diagram, please clarify, analyze and write them in a rough worksheet or in a side of the paper. You write all the things. So when you read the question, you can use that as a resource. Remember that. You can manage the time as well. Okay, understand? Quickly go to the next one. Name the function of the blood vessel R.
Taking blood away from heart to lungs.
Heart to
Deoxy-
lungs. Yes. Carry the deoxygenated blood. They're asking about R, no? Yeah. Carry the deoxygenated blood from heart to lungs. Okay, that's the answer. Okay, now we have come to another interesting part, plant and animal cells. Right? Before that one, I will go through the structure of the plant and animal cell quickly, children. So look at that one, and also I will show you a small animation video about that. So you can get the clear idea about that. You see? Right. So if you take a plant and animal cell, plant cell has a cell wall. Right? It has a cell wall. But animal cell doesn't have a cell wall. It has only a plasma. Remember, in plant and animal cells, we have three structures. And other all are organelles. The small things can be seen in the cytoplasm that are organelles. Other are structures. So structures are cell wall, plasma membrane and cytoplasm. Right? So here plant cell only has the cell wall. Right? And after that it has a plasma membrane. Cell wall, plasma membrane, and this surface is called what? Cytoplasm, right? This is what the cell wall, remember, okay? This is the cell wall. The red color line is cell wall. And this layer is the plasma membrane. And this surface is called cytoplasm. This is about plant cell. This is the plant, right? Then we go to the animal cell. Animal cell doesn't have they don't have a cell wall. We animal cells have only a plasma membrane and a cytoplasm. Right? Plasma membrane and cytoplasm. Remember that, okay? Right. Next thing, children. What are the other organelles now? Right? This cytoplasm is a jelly-like medium, gelatinous medium, jelly wage, right? So, it can maintain the shape of the cell. Once we set a jelly, what will happen? We can't change the shape, no? Like the same way, cytoplasm is a good gelatinous medium, gelatinous liquid. So, it maintains the shape of the cell constantly, right? And cell wall is like the walls of our houses. What is the use of the walls of our house? What we get from the walls? Jack එකක් දාගෙන ඉන්නද නෑනේ? හේතු වෙලා ඉන්නේ නෙමෙයිනේ. What? Protection, no? Right? So cell wall is giving a protection. Right? Like the walls giving protection in our house. Right? Okay, cell walls are giving a protection. And children, remember, the outside layer is plasma membrane. No? Plasma membrane also giving a protection in one specific way. Right? Plasma membrane is just like our doors and windows. So doors and windows also giving a protection to us, but in a specific way. How? In our houses, by using the doors and windows, we can control the entry and exit of the people out from the house, out to house and into the house. Right? So if the doors and windows are closed, no one can go outside, no one can come inside. Same thing happens by the plasma membrane. Remember like that. Plasma membrane is like doors and windows. It controls the entry and exit of the cells. Then plasma membrane is the one who decide who can come into the cell, who can come out of the cell. So then this plasma membrane is called a semi-permeable membrane. Okay? It only lets some specific materials to come inside and go outside. Okay, so then animal cells doesn't have a cell wall to protect, but plasma membrane is there to protect. It's also giving a protection, right? Okay, then cytoplasm. Cytoplasm is a gelatinous medium. It help to maintain the shape of the cell, right? And also it is bear all the cell organelles. All the things are on there. So cytoplasm is like a table. Now in the table you have right now, you have kept so many things, laptop, phone, books, everything are there. No? So table is what? Bearing the things, right? So cytoplasm also bear the organelles. So because these organelles are doing the metabolics means the biochemical reactions inside the cells. So these are individually done by the cell organelles. So as these cytoplasm bear the cell organelles, it helps to complete the metabolics. Okay, complete the biochemical reactions in the cell. Okay, these are the main functions. Remember, cell wall give protection, right? And also cell wall is the dead structure of the cell, and it is made of cellulose. Cellulose is a polysaccharide. And when you go to cell plasma membrane is like our doors and windows. It is controlling the entry and exit of the materials out of the cell and into the cell, right? And cytoplasm, it's a gelatinous liquid and it bear the cell organelles, help in metabolics. Okay, right? We'll see what are the other organelles. Remember, in plant cells, they have a large central vacuole. ඔයාලා vacuole එකක් හිතා ගන්න like a water bubble. නිකන් හරිද එහෙම හිතා ගන්න. So when a water bubble comes to here, right? Cytoplasm. නිකන් හිතන් cytoplasm has to go peripherally pushes outward to give the space for the vacuole, because vacuole in a plant cell is taking the largest space in the cytoplasm. But in animal cell doesn't have large central vacuoles. Sometimes not a single vacuole, sometimes a small vacuole, don't even consider. Right? So, in the animal cell, cytoplasm takes the whole space, but here cytoplasm peripherally pushes outward to give the space for large central vacuole. What is a vacuole? Vacuole contains some specific things only. It contains water, it contains sugar, ions, and pigments. What is, children, pigments? Pigments means some colors, natural colors. All the things are inside that one. So as the vacuole has water, vacuole helps to maintain the water balance in cell, right? As the sugar, ions are there, so vacuole give the support, strength to the cell, right? So, and as it has pigments, whenever cell needs a color for any metabolic, it provides colors as well. Quickly go to the next one, mitochondria. Mitochondria can be seen in both cells. Mitochondria, like, what is the word we nickname given to the mitochondria? What is it?
Nucleus.
Powerhouse. Why? Because in aerobic respirations and anaerobic respirations, the energy produced by that one is stored inside the mitochondria, and whenever it needs, it releases the energy, right? So mitochondria. And then Golgi bodies. They are like different layers stacked. They have attached top of each other. These are called Golgi bodies, right? So what they are doing? They are like factories, children, remember. They are like a factory. They do production, packaging, and releasing. What are the things? Secretory substances, the things which are secreted, released from the cells. So those are done by that one. They produce the secretory substances, package them, and whenever it is needed, they do the secretion. They release the secretory substances. So that one. Okay. When you go more, there is a very special thing which is called nucleus. Nucleus is like the control panel, right? Nucleus is a control panel. Nucleus is like a sphere, ball එකක් වගේ, right? Inside that one there is another point which is called nucleolus. Then ඔයගොල්ලෝ animation video එක බලුවම you can understand the 3D version of that one. Here we can't draw the 3D version. So you just imagine there is a ball, right? Inside that one at the middle there is a small point, that is nucleolus. Nucleolus is the one who produces ribosomes. Right? So who are ribosomes? Ribosomes can be seen from the microscope like dots because they are smaller than the other organelles. So the ribosomes have special ability to produce protein. Now, around the nucleus, there is a special tubular structure which are called endoplasmic reticulums, children. Endoplasmic reticulum. Right? Right? These endoplasmic reticulums, right? Some other endoplasmic reticulums are also there in several ways. They are like tubular structures. Here also same. You can see the difference between this and this. They have separated layers, but here it's a tubular shape. They have not separated completely. Right. The ribosomes that are produced by the nucleolus inside the nucleus comes out now. So when they make a endoplasmic reticulum, these ribosomes have a habit to attach on the endoplasmic reticulum. Not every time, most of the times. Okay. So then they attach on there. Because the ribosomes attach on the endoplasmic reticulums, the substrate of the endoplasmic reticulum becomes rough. So we call it as rough endoplasmic reticulum. So normally these endoplasmic reticulums have a tubular shape. They have adapted to transport something, every time to transport something, right? So as the ribosomes are in the endoplasmic reticulum, the proteins synthesized by the ribosomes are transported within the cells by the rough endoplasmic reticulum. Then what about the smooth endoplasmic reticulums? They don't have ribosomes, no. So what they are transporting? Then they have to produce something else and transport it. What is that something else? Tell me. What's the endoplasmic reticulum production?
Hormones.
Lipids and steroids. Okay, lipids and steroids. They don't have ribosomes to supply the proteins to transport. No, they have nothing to transport. Then they supply something else and transport it. What is it? Lipids and steroids are transported, producing and transporting by the smooth endoplasmic reticulum. So that's all about ribosomes. Some ribosomes can be seen from place to place in the cytoplasm as well, and sometimes on the endoplasmic reticulums. Okay, right. So these are the main thing. And one more organelle, we forgot it. Tell me what it is.
Chloroplast.
Chloroplast.
Chloroplast. Okay. Is it in the both structures?
No, only in
Did
plant.
not.
No, it's in the plant cell, right? Very good. Right? It's in the plant cell. So this is what? Right? So this is chloroplast. Chloroplast is the cell organelle which produces chlorophyll and helps in photosynthesis. Okay, children? So we will go to the animation video and go back to the question, right? Okay, I'm going to share the video. You can watch that.
Okay.
Children, because of a small problem at the end of the video only, we heard the noise. Okay. Okay, children. Sorry for the interruption. Hope you can hear me. Right, we will continue that. We will go to the question now. I think you will have a proper, even though the sound was not there, you could see the animation. No? So then I think you would be able to understand this structure using the video, right? Okay. Now, before I am going to this question, you write the answer for this question. This is a past paper question. Now you can recall the things you saw in the animation video. And while recalling the things I explained using the diagram, you try to write the answer for this. Right? Hope it is clear. Only for this question, right? This question. Okay, we will discuss together, right? We want to manage the time now. So, see, given below is a diagram of a typical plant cell drawn based on the electron microscopic observations. By which letter is the structure that helps to maintain the shape of plant cells named? Tell me by which letter. And before that one, we will clarify what are these structures. They tell this is a plant cell. Okay, then P is what? Tell me what is the P?
Cell wall.
Cell wall.
Cell wall. Yes, the outest one, no. So this is a cell wall, right? Okay, chloroplast is there. What is R, children?
Nuclear envelope.
Nucleus. It's nucleus. Right. And mitochondria is there. What is S?
Vacuole.
Yes, vacuole. Q?
Plasma membrane.
Plasma membrane.
Plasma membrane. Okay. Do you remember what is the other similar word used for plasma membrane?
Membrane.
Cell membrane. Yes, good. T is what?
Golgi body.
Golgi complex.
Golgi bodies or Golgi complex. Complex or body, okay? Right. Now, see. By which letter is the structure that helps to maintain the shape of plant cell name? Tell me.
P.
P. According to this one, P is the answer, right? If there is any doubt, please ask me. Next one, write the names of the organelles labeled Q and T in the relevant boxes. What is Q, what is T? We have named it plasma membrane and Golgi bodies, okay? Golgi complex or Golgi bodies. By what letter is the organelle that can also be identified when observed under the optical microscope label? What is it?
R. R.
R, right? That is nucleus. That is the first thing we can observe from the compound microscope. Right, next one. State the function carried out by the following organelles.
Containing
Chloroplast. What it is?
photosynthesis.
Produce
Yeah,
chlorophyll.
helps in. You just don't write photosynthesis, Puta, right? Helps in. This is a bio one, no? Helps in photosynthesis or carry out photosynthesis, right? Okay.
Teacher, what about
Mitochondria?
producing chlorophyll?
Yeah, producing chlorophyll also correct. Both are correct. Okay. An alternate answer, producing chlorophyll. That's also correct. Mitochondria?
Producing energy. Then carry out aerobic respiration.
Aerobic energy production.
You can write store and release energy for metabolics or store and release energy or release energy. Those all are correct, right? But not produce energy, right? Energy is produced in the respiration, okay? So we better to write store or release energy for metabolics, right? Okay, right. Now we are going to our paper question. It's a small question. Now, every time don't expect the same beautiful structure would come. They will give you another rough structure. However, you want to identify according to the theory. That's why I am telling don't memorize. If you are memorizing, you expect the same appearance. Not like that. Understand the logic and the fact and try to answer the questions. Okay. Right. See this one given below is a sketch of a animal cell. Animal cell drawn by the observation under the light microscope. Okay, children. See, it's an animal cell now. Can this be cell wall?
No.
Can this be cell wall? No, it's not the
No.
cell wall. It's called plasma membrane. The outside one is plasma membrane. Okay, just we will go through this one. What is Q then?
Nucleus.
Nucleus.
Nucleus. Very good. Nucleus. What is R?
Ribosome.
Yeah, sorry. Don't misunderstand the ribosome. They try to point out the cytoplasm. Okay? Right. I thought you will be like that, but the ribosomes are not everywhere like that. So that's the main fact we can construct for that. Okay? That's the clue. Right. Okay. Right. What can be P and R? We have already learned that. Okay, children, another thing I want to tell you is if you just write plasma membrane, cytoplasm, that's okay, but marking scheme clearly appoint the examiner to give the marks that have clearly appointed the answers. Right? So write P dash plasma membrane. This is not a structured essay question also, we can't use this box as well. We are not giving this paper, right? We are writing in an extra paper. So write P is this, R is this, like that you have to write. Okay, please write like that. Okay, next one. State a function of R. Tell me.
Protecting the cells.
Sorry.
Protecting the cell.
Protecting the cell. Cytoplasm is protecting the cell.
Bearing organelles.
I told you three things. Protection is done by cell wall and the plasma membrane. Okay. Cytoplasm not doing that. It has three other functions. What I told you to substitute the cytoplasm to a table. Table is doing what? It is bearing the things we place there. No? What are the things on the cell? The cell
Organelles.
organelles. So we can say cytoplasm bear cell organelles. Right? The other thing, I told you it's a gelatinous liquid. Right? It's like a jelly. So jelly is maintaining a shape of the cell. Then children, so we can write that one as well. What? Maintain the shape of the cell, right? Third thing, right? I told you they bear the cytoplasm bear the cell organelles. So cell organelles are doing the metabolics. Then cytoplasm carry out metabolics, right? So what are the three things you can say? Now tell me.
Bears the cell organelles, provides shape to the cell, and carry out metabolic activities.
Yeah, maintain or provide. Better to write maintain the shape of the cell or provide the shape of the cell, and bear the cell organelles, carry out metabolics or helps in metabolics, right? Okay. Name an animal cell which does not contain the organelle R. What is it?
Red blood cell.
Red blood cell.
Yeah, name an animal cell which does not contain the organelle R is red
RBC.
blood cells. Red blood cells do not have a nucleus, right? It has a biconcave shape only. We know that biconcave shape we think there is a nucleus. No nucleus is there. It's a thallus shape, biconcave shape. So, red blood cells, RBC. Remember children, this is what we are learning as the example in O-level syllabus as the animal cell which do not have a nucleus, that is RBC or red blood cell. Write an organelle or a structure which is impossible to be seen in animal cells but possible to be seen in plant cells.
Chloroplast.
Cell wall or chloroplast.
Chloroplast. Okay. No, not chloroplast. Chloroplast not in animal cell, only in plant cell. Yeah, that fact is correct. But see what they ask. Cell organelle or a structure. They are giving. I want to tell you that. Okay, organelle or cell, you have freedom to write either organelle or cell. So chloroplast also correct. I saw only the structure part. So structure, cell wall. Alright. By any case, if they ask the question, write a structure in cell which is impossible to see in animal cell but in plant cells. Then what it could be?
Cell wall.
Then cell wall. Okay. So remember that. Okay. So then they have given an organelle or a structure. So then yes, correct. You can write either chloroplast or cell wall. Both can be written. Okay. Right. Name the polysaccharide contains in the plant cell wall. I told
Cellulose.
it. Cellulose. Very good. Okay. Now here we are going to the sixth question. If you has any doubt, please ask me or put the inbox message. I will see it later. Okay. Tell me children, by looking at this question, this is associated with which lesson? Hydrocarbons. Right, hydrocarbons. It's a very short lesson and also it has a limited theoretical parts. Don't memorize. By understanding the facts, we will try to revise it. Okay, remember, Hydrocarbons. What are hydrocarbons?
Compounds with C and H only in a fixed ratio.
Yeah. So we can write the hydrocarbons are organic compounds. Okay, organic compounds. Or you can just write compounds. Then also they will give marks. Compounds which contains only carbon and hydrogen. We say only carbon and hydrogen because that's the main thing. But remember, there are some few examples are there of hydrocarbons. They have a very small amount of other elements like nitrogen, oxygen, sulfur, right? But that's not much considerable. When you compare with the number of carbons and hydrogen contains there, that other element contains in a very, very small amount. Not only every, majority, very 1 or 2 instances are there, right? When consider all together. So remember, so hydrocarbons are the organic compounds which contains only carbon and hydrogen. So there are 3 types of hydrocarbons, children. 3 types. What are these groups?
Alkane, alkene, and alkynes.
Yes, alkanes, alkenes, alkynes. Right? So according to the type of bond among the carbon atoms. Okay, if any hydrocarbon has only the single bonds among carbon atoms, only single bonds, right? Then they are alkanes, and their names are also ended up with ane. Right? Methane, ethane, if there are 3 carbons propane, 4 carbons butane, 5 carbons pentane, hexane, like that, octane, everything are coming, and octane is the petrol. Okay? Alkenes. Alkenes means carbon single bonds are there. That means if there is at least one carbon single double bond, at least one carbon double bond, that is going to the category of alkene. Okay? Last one is alkynes. They have carbon triple bonds. If the compound at least has one carbon triple bond, normally carbon triple bonds and single bonds are coming, double and triples are not coming, okay? So at least there is a carbon triple bond, that is a alkyne. But fortunately, we have only very short content of this lesson, no? So we have to learn about alkanes and alkenes only. This is just a basic idea. Okay, so in alkanes we are learning so many instances, examples. What? Methane, ethane, propane, butane, pentane, and we learn how to draw their chemical structure as well, right? And when you go to alkenes, we are learning the first basic structural example of alkene only, the basic alkene, that is ethene. Who remembers ethene? What is the formula of ethene, children?
C2H4.
C2H4. So, carbon double bond. And 4 hydrogens around that. That is ethene, okay? And its derivatives. Ethene has, we are doing some replacements of other atoms instead of hydrogen, and we are making some other derivatives, varieties of ethene. So we can substitute chlorine, one chlorine atom instead of hydrogen. Then you will have chloroethene. Okay, chloroethene, right? Or otherwise you can substitute 4 fluorines instead of the 4 hydrogens. Then you will have 4, no children, 4 means tetra. So tetrafluoroethene, remember. Do you remember carbon tetrachloride? CCl4. Tetra means that prefix is given in chemistry to represent number 4. So 4 fluorines are there, no? Tetrafluoroethene. Ethene is CC double bond. Okay, that's the thing, right? So these are the main things. So by taking them and repeating the same molecule a large number of times like a chain, what we produce? We produce polymers. That process is called polymerization. When you use ethene to polymerize, right? Ethene to polymerize, ethene becomes the monomer, right? And tell me, what's the name of the polymer of ethene?
Polyethylene.
Polyethylene, right? Polyethylene is the chemical name. Our usual name is what? Polythene. Very good. So its monomer is what? Monomer is ethene. So when you are drawing a monomer, children, right? We will clear all. We are drawing a monomer. First see if the monomer, if it is about polyethylene, polyethylene. Ethene becomes polymerized. Okay? So ethene is this, no? This is the way of ethene. This is ethene. So it is have to be repeated as a monomer. Then it is repeating like this. So this bond getting rigid because more and more have to be arranged in the both sides like a chain, right? So this is the repeating unit, right? So when you put N here, we symbolize that it has polymerized. This is what? Polythene. This is what? Ethene or monomer, right? Right. So chloroethene, what's the polymer of chloroethene?
PVC, polyvinyl chloride,
Polyvinyl chloride. For tetrafluoroethene,
Teflon,
Teflon or chemical name is polytetrafluoroethene. Quickly we'll go to that next one. See it is, right, see, P, Q and R. So this is what?
propane,
3 carbons are there. So propane, this is propane. This is what?
ethene,
Ethene. This is a special one. What is it?
isoprene,
Who remembers? Isoprene. Isoprene is the monomer of rubber. It's a natural polymer. We don't produce them. Okay. See, characteristics and the hydrocarbon belongs to the alkene group. Ene means double bonds. Who has the carbon double bond? Q, no? Then answer is what? Q. We won't write the letter only. Right? A constituent of LP gas. What is it, children?
P,
P, propane. Last one is a monomer of a natural polymer, rubber, Q. Sorry, R. Right. Now we'll go to this one. The hydrocarbon octane C8 8H18 is the main component in petrol. Explain briefly about hydrocarbons. I told you what it is. The organic compounds which contains only carbon and hydrogen. Based on the common formula of the alkanes, verify that octane belongs to the alkane series. Who remembers the common formula of alkanes?
CnH2n plus 2.
H2n plus 2. We'll see is it verified by this one. C8. What is C here? Number of C. It's 2i's plus 2 should be 8. We'll see is it correct. Okay. C8 no. So H also should be 8 into 2 plus 2. Make a maybe the pen one right? So answer is 18. This is how to write that one. Verification. Okay. Right. Next one. Name an alkane. Name an alkane that exists in gaseous state at the room temperature. What's it? It's an example for alkane, but it's a
Methane,
gas. The very first one, methane. Okay, or
Methane.
we call it methane. CH4. Okay, right. Because methane is in a biogas as well, right? You have to remember that. Right, next one. Incomplete balanced equation to complete combustion of octane is given below. Right, octane is completely combusted. As it is completely combusted, carbon dioxide and water is produced. That's a normal thing. If anything is completely combusted, carbon dioxide is formed. As it is a hydrocarbon, water is also produced. See, what are the suitable values for X and Y? Tell me. How many carbons are there, children? 2 into 8, 16. Then there should be 16. How many hydrogens are there? 2 into 18. There is already 2 here. Then there should be 18. Easy, right? So X equals 16, Y equals 18. That's how to deliver the answer, right? Calculate the mass of carbon dioxide released by the complete combustion of octane. This is a chemical calculation. I wanted to give you that because most of students skip the chemical calculation. That's not much hard. Okay, remember for chemical calculations we need some special formulas, right? What are those special formulas? We have these basic formulas for that. Capital M equals simple M over N. Molar mass equals mass over number of moles. How do you find out the molar mass? Take the relative atomic masses of each atom and add them together. Right? Okay. So we'll see. What's the question they have given? They are asking, calculate the mass of carbon dioxide. Right, released by the complete combustion of octane. Right, now they have given some relative atomic masses, carbon, hydrogen, oxygen, 12, 1 and 16. Right, then first thing we can find out is about what we can first find out. Mass is carbon dioxide. Before finding the mass, we want to find out the number of moles. Do you know the number of moles? We don't know the number of moles of anything, right? Then how do you clarify this? You have balanced the equation, no? Right? How many molecules are there then? How many molecules are there?
32.
Carbon dioxide molecules?
16 molecules.
16, no? Not oxygen. I'm asking carbon dioxide molecules. How many are there? 16 are there, right? Can we take it as 16? So we can substitute that value, no? Right? Okay, I will make this little bit easy. See that this one, there is octane, oxygen, carbon dioxide, water, right? I will tell you the mass of the octane here. Mass of the octane. Mass of the octane, take it as 20 grams. This is just a practice question, not the main one. Right, they are telling 20 grams of octane is produced. Right? So carbon is 12, hydrogen is 1. Find the molar mass of 8. First of all, find the molar mass of octane and take this mass and find out the number of moles of octane first of all. Do it here. How do you do that one? Writing M of C8H18. What is it? How many carbons are there? 8 into 12 plus 1 into 18. 96 plus 18. What's the answer?
114.
114 grams per mole. Right. We'll use this one. 20 over 114, 20 over n. Right? So You can change this as we have a limited time. We will quickly go through that one. So what is the answer you will get? 20 over 114. N equals 20 over 114. You will have 10, 5, 7. Right? So we'll take 10 over 57 moles.
5.7.
Right? So what can be the decimal answer? You just take a
5.7.
nearby answer. 10 divided by 57. 0.2. Nearby one, okay? 0.2 moles. Right, children? Now when you go back to the question, right? This has 0.2. Right? Okay. This has how much? Now think 2 to 16 ratio is there, no? Right? If octane is 2, how many carbon dioxide molecules are produced? 16. So then 1 and 8, 1 to 8, right? If one molecule is produced, 8 molecules are producing. Every time it's 8 times. If the amount of carbon dioxide production is twice the octane production. So then if the 0.2 moles of octane is producing here, it's 8 times production is the carbon dioxide. Now then tell me how many moles of carbon dioxide are producing here? Octane is 0.2 moles. Then carbon dioxide is 0.2 into 8. Then 1.6 moles. Right? Okay. Now we are going to that part again. Right. Now they ask the carbon dioxide, no? Right? They have missed that details. That's why. Okay. So first find the M of carbon dioxide. It will be what? What's the molar mass of carbon dioxide? 12 plus 16 into 2, 32, 44, right? So we can write M equals M over N, right? 44 equals, M is the one we have to find out, over 1.6. So when you multiply it, you have M equals 44 into 1.6. What's the answer? 70.4 grams. Right? So don't expect every time they are telling about they ask the mass or something of carbon dioxide and not delivering important detail. Then definitely using another part of the same reaction, you want to find out the answer. Okay? Right. So they have missed their children. So you write it here. They're asking calculate the mass of carbon dioxide released by the complete combustion of octane. No? So also you write here octane is used in 20 grams. That's what we missed. That's why we couldn't clarify the question. The detail has missed there. Next one, draw an energy level diagram for this reaction. For energy level diagrams, children, exothermic, endothermic, so on. So here what's happening? Tell me, is it an exothermic reaction or endothermic reaction? It's a combustion. Then it should be what? Tell me. Exothermic. Why is that? In a combustion, definitely it is exothermic reaction. So, children, in the energy level diagrams, right? In energy level diagrams, what should be in the upper level? This is the energy level diagram, no? This is energy. Reactants or products should be in the upper level.
Reactants.
Reactants should be in upper level. So then write the reactants with the balanced numbers 2C8H18 plus 25O2. In down 16CO2 plus 18H2O. Right? If you wrote that one, that's correct. Then Lewis structure, quickly we'll go to that part. Draw the Lewis structure of the carbon dioxide molecule which is obtained as a gaseous product. Carbon dioxide, Lewis structures. That's also another part. Now, one of you has asked in teacher, may I know what? Since I have the highest yield of marks from 0. Right. Remember, if you are cover up the periodic table, the thing we have discussed from the morning, these all are very important. If you can be familiar with these things, you can upgrade your marks, right? Because don't want to memorize each and every lesson. First, take the past paper book and try and see and examine what are the lessons, usual lessons, and what are the lessons based on the main questions. Because when you see the second paper, every time you can see the same lessons. Same lessons are associated with the second part paper questions. So if you can revise them and clear all the confusions and doubts of that sections, then you can upgrade your marks. So these times you spend your time for that one, and also try to do more and more past paper questions taking some specific lessons. You take the periodic table, and as I told you today, you revise all these key points and key factors and take 5 or 4 years only the questions based on that part and do them. Then you will have a clear idea and you will have a well practice. You can practice well that type of questions. Again, you will not scare on that one. Then you can definitely sure about the marks of that type of sections. That's the way you can do here, right? Just go, don't skip the chemistry questions. That's what I'm telling, right? Okay. Now, we'll quickly go to the carbon dioxide molecules, CO2, right? So, what can be the center atom, children?
C.
Carbon or oxygen? Carbon is the center atom, no? Oxygen at 2 sides. Remember, carbon has 4 electrons. Carbon has 4 electrons in the valence shell. Oxygen has 2 electrons in the 6 electrons in the valence shell. Right? Carbon expecting 4 more. Right? Oxygen is expecting 2 more. But there are 2 oxygens. Right? Right. Now, carbon, if carbon in Lewis structures, we draw the Lewis structures in covalent bonds here, no, mainly in our O-level syllabus. So, in the covalent bonds, they expect to share the electrons, right? If someone needs to share, if someone needs amount of electrons, that much needed to be shared with others. Example, if carbon needs 4 electrons to be stable. First, it needs to share that 4 electrons with other atoms. Otherwise, it cannot gather that electrons, no? Right? So, then as carbon is 2, 4, it needs to share 4 electrons with others. Then only it will get another 4 electrons from others. Now, there are another 2 participants, 2, 6, 2, 6. They need 2, right? So then carbon thinks, okay, if you need 2 electrons, I will give 2 to share. You also give 2 to share. Here also same. Okay, if you also need 2 electrons, I will give 2 electrons to you. You also give me 2 electrons. That's how they are sharing, right? So then carbon is sharing 4 electrons. 2 with first atom, another 2 with other atom. So then all the 4 electrons in the valence shell has shared, no remainings. When you go to this oxygen, oxygen had 6 electrons in the valence shell and it has given 2 electrons to share. 2 electrons to share with them and other 4 remaining are there. Right? This oxygen also same, it's giving 2 electrons to share but 4 electrons are remaining. 2 are given, 4 are remaining. Right? Then these shared, each couple of shared electrons are representing a straight line. Then for this 1, 2, 3, 4 and the remaining electrons should be mentioned there. So that's the thing. This is the Lewis structure. Okay, please practice the Lewis structure at home. That is very important. Okay, children. So as we are running time, we will have to go through this one quickly. I will show you a small video about this one and quickly we'll go through the answers for this question, children. Okay.
La fotosíntesis es el proceso por el cual las plantas fila. Los cloroplano gaseoso es un subproducto importante del proceso de fotosíntesis. La fotosíntesis
Don't mind the
ocurre en luz y
language.
una reacción de oscuridad. El almidón se forma. En este experimento, demostraremos mediante una sencilla configuración experimental que el oxígeno gaseoso se desprende como subproducto durante el proceso de fotosíntesis en las plantas verdes. Para realizar este experimento, necesitarás lo siguiente: un vaso de precipitados grande lleno de agua, un embudo
Please wait.
acuática como hidrillá, cara, elodia, etc. Para comenzar el experimento, toma algunos brotes de la planta acuática e inserta los extremos cortados de sus tallos en el tubo del embudo de esta manera. Sumerge rápida pero cuidadosamente el embudo en el fondo del vaso de precipitados que contiene agua, como se ve aquí. Ahora llena el tubo de ensayo hasta el borde con agua. Sujeta la boca del tubo con el pulgar e invierte el tubo en el vaso de precipitados y déjalo reposar sobre el tubo del embudo como se muestra en el video. La
See what's
configuración ya
happening.
está completa. También puedes agregar una pizca de bicarbonato de sodio o potasio en el vaso de precipitados para iniciar el proceso de
So
fotosíntesis.
here they
Coloca el montaje a la
add
luz
the
del sol.
carbon
Unos
dioxide.
minutos después de la exposición a la luz
See
del
that
sol,
one.
notarás
First
que
I
se
will
desprenden pequeñas
explain.
burbujas de aire de los extremos cortados del tallo de la planta acuática. Estas burbujas de aire ascienden por el tubo del embudo y finalmente se acumulan en el extremo superior del tubo de ensayo. A medida que pasa el tiempo, se acumulan más burbujas de aire en el tubo de ensayo. Deja el montaje a la luz del sol hasta que el tubo de ensayo se llene completamente con el gas. Ahora, retira con cuidado el tubo de ensayo del vaso de precipitados mientras cubres la boca del tubo con el pulgar.
See the splinter
Retira el
test.
pulgar e introduce inmediatamente una astilla incandescente en el tubo de ensayo. Notarás que la astilla incandescente se vuelve a encender con un chasquido. Esta prueba confirma que el gas producido por la planta acuática y recogido en el tubo de ensayo es efectivamente oxígeno. Este sencillo experimento demuestra así.
Okay. Now children, you can see that that is the main experiment they have done here. So don't mind the language, right? So as it was a clear video, that's why I chose it to show you. That's about the production of oxygen, how by a laboratory experiment show that oxygen is produced during the photosynthesis process, right? This is the same setup you can see here. In there, they have used a glass funnel, a beaker, water beaker, glass funnel, an aquatic plant and a test tube. Here there are some key points I want to remind you about is why we are using hydrilla or any other aquatic plant. Why do you use an aquatic plant, children? Tell me.
Because it can do photosynthesis underwater.
Yeah, because we have to do this experiment underwater. So, if you use a normal terrestrial plants are not adapted to do all the biochemical things inside water, no? So, as we want to do the experiment in underwater, that's why we are using an aquatic plant, okay? That is a usual question. If you have done several past paper questions based on photosynthesis, I think you have met that question in several times. Okay, that's the most common question. Next thing, if they ask, why do you conduct this experiment in underwater? Why? Why do you do that one underwater? Why do you do the experiment in water? Other experiments are done in land area, no, not in water. So why?
To see the gas flowing, the gas bubbles for us
Yes,
to
very
clear
good.
for us to
To
see.
observe the gas bubbles. Yes, because our target is showing, confirming scientifically a gas is produced in photosynthesis, and second task is that gas is oxygen. Two things to be confirmed, no? So first thing to be confirmed, normally gases, if it is an oxygen gas, it's a colorless gas. We can't see it is going, right? So to observe the gases, colorless gases, the one and only thing is, not one and only thing, a very successful way is using water. So when the gas bubbles are liberated from water, we can identify it, we can observe it. That's why we are doing it. So what is the reason for that one? To observe the air bubbles or gas bubbles. Okay, then as we want to confirm that it's exactly oxygen gas, then what you are doing? After this air collected to the test tube, take it out and doing a splinter test. And also remember, you can't just write burning a splinter, not burning a splinter, burning a glowing splinter or reigniting a glowing splinter. Glowing word is important, right? What is the observation can be made sometime after the setup is arranged in this manner? Gas bubbles are liberated. What test should be done to arrive at the conclusion on the observation obtained above? What is the test? Reigniting a glowing splinter. What is the they asking should be done? So reigniting the glowing splinter and observing a bright flame. Okay, what is the conclusion can be made on this experiment? What's the conclusion?
O2 is released as the byproduct.
Yes, oxygen is released during photosynthesis. Okay, children? Right. Okay. So, these all are I have explained up to now. Right? So, then I think you got a clear, better idea about the questions we did today about periodic table, the chemical reactions. My main target was today is to give a clear idea about some important chemistry sections. So that's why I selected some chemistry questions mainly, and I took more time to explain that. And also as I choose that plant and animal cell one, photosynthesis one, and that time graphs, because again I am recommend you to take your past paper book and see every year second paper questions. You can see the velocity time graphs, ST graphs, the motion in a straight line, periodic table, chemical reactions, activity series, photosynthesis experiments are very useful and very popular in every year second paper. So that's why I thought to do that one. So I thought to do some other current electricity lessons as well, but we don't have time, we have run our time. So we have to finish. However, you have two other science sessions. So the parts I couldn't discuss during the today's session will be discussed in the other two science seminar sessions. So please participate for that one, and don't forget what I said you. Don't forget the tricky techniques I told you. Please practice them and don't give up on chemistry, physics, and some basic hydrocarbon, that type of lessons. Don't give up on them. Work hard until the end and just don't memorize the lessons, okay? Just understand the logic, clear your confusions these days, meeting your teachers and participating to the seminars, and as much as possible try to understand the logic and the practical fact of the lessons, then you will have good marks, okay? So children, thank you for joining with us. Hope you will participate our other seminar sessions as well. Okay, good luck. Thank you. God bless.